that's going to come up to the podium to present, would you please sit in the front row? So again, anyone presenting, your teams, whoever is going to be getting up to the podium, would you please sit in? Okay, good morning, everyone. I'd like to call this meeting to order. Ms. Huerta, would you please call the roll?
Mayor Paulette Guajardo.
Present.
Council members Roland Barrera.
Here.
Sylvia Campos. Here. Eric Cantu. He'll be joining us at about 10:30 virtually. Gil Hernandez. Here. Kaylin Paxson. Here. Everett Roy. Mr. Roy, I've seen him here, but he'll be about 30 minutes late. Mark Scott.
Here.
Carolyn Vaughn.
Here.
City Manager Peter Zanoni.
Present.
City Attorney Miles Risley. Here. Mayor and Council, a quorum of the Council and the required charter officers are present to conduct the meeting.
Thank you, Ms. Huerta. So good morning, everyone. Welcome to City Hall and Council Chambers. I want to first start by saying the tremendous, we're here about water, and I just want to give a little glimpse as to the tremendous progress that the city has had with our own desalination project, which you'll hear about shortly. But it will be the first municipal seawater desalination plant in the country. It's very exciting because earlier this week, and I wanted to let everybody know as well, we convened at the Capitol by the direction of Senator Adam Hinojosa and Senator Chuy Hinojosa, and it was a very good meeting. It's about water. It was about coming together. We formed an alliance, the Coastal Bend Water Alliance, which is going to be a group that consists of all of our partnerships across the Coastal Bend to advocate for and to talk about and see what water solutions we need to go after, if you will. So as Senator Hinojosa put it, the city of Corpus Christi is at the 1 yard line. That's very exciting. Within a week, we'll be hopefully crossing the goal line. And so today's workshop is also an important step, very important step, as we turn our attention to the next phase, exploring what the next alternative water solution is. We understand that, our desalination plan is certainly a solution in June of 28, but we also have to continue to look for water solutions, and that's what we're going to have presentations today, as you all know. So I want to thank all the presenters for being here. I want to thank our staff, Drew Molly, for your leadership. And what we're going to do is have our presenters, I'm going to turn it over to Rebecca in just a moment. She'll explain the process by which we will, this workshop will take place for the next few hours. So thank you. Rebecca.
Thank you, Mayor. So we'll start with the other candidate water supply projects, and that's going to run approximately from 10 to 12:30 p.m. Each presenter will have 10 minutes to present their alternative water supply project. And all 6 projects, and these are 1A through F, they're Eevee Ranch, Evangeline, Barney Davis, Port of CC Harbor Island Permit, Solar Panel Installation, Nueces River Authority Desal Plan. That's the order. They will be, all 6 projects will be consecutively presented prior to answering questions from City Council members. And after the last presentation is concluded, I'll ask all the presenters, the first presenter to reassemble at the podium and address any questions from City Council members. Each City Council member will have up to 10 minutes to ask questions of the presenters. Then we'll take a brief recess between 12:30 and 1 p.m. And we'll resume from 1 to 2:30 p.m. And with the exception of the wastewater reuse project, that'll have 10 minutes. Each presenter will have 5 minutes to present their respective projects. And all 6 projects will be consecutively presented prior to answering questions from City Council members. And then each City Council member will have up to 5 minutes to ask questions of the presenters. So that's the process we'll be using today.
Yes, right.
So we'll start with the first project. The first project is Eevee Ranch.
Well, good morning, ladies and gentlemen of City Council, Mayor Guajardo. I'm Mike Mintz. The Eevee Ranch project, many of you are familiar with. It's a southern water supply that can provide a source of water from the Catahoula Reservoir. Next slide, please. Or can I do it here? Oh, perfect. Okay, so this is a 30,000-foot elevation. In the lower left is a depiction of the 100,000-acre ranch with the water lease. We propose to lay a 46-mile, 48-inch water pipe that will connect in Kingsville with the South Texas Water Authority. This pipeline exists now. It is at only 20% capacity. It is using 7,000 acre feet a year that is provided from the city. By reversing this, that 7,000 acres will remain with the city. You'll have a net gain of 32,000 acre feet, or 28.5 million gallons a day. This is the key. This slide shows the Catahoula Aquifer. The Catahoula Aquifer extends from about 500 feet below surface to 2,500 feet. The aquifer has a very low total dissolved solids in the range of 1,500 to 3,000 parts per million compared to seawater, which is 35,000 parts per million. The aquifer has the ability to provide water indefinitely. We're based upon a 50-year model, but after 50 years, the drawdown in this aquifer is approximately 3%. The aquifer, over 100,000 acre lease at 2,000 feet of thickness, contains 65 trillion gallons of water. 65 trillion gallons of very low saline water. The comparison to Lake Texana is you could stack 2,000 Lake Texanas, which contain 31 billion gallons. You could stack 2,000 Lake Texanas on this reservoir to equal the volume. So that's a vertical depiction of the reservoir. If you look at this slide, it tells you why this is so unique. This slide demonstrates the areas in South Texas where you would have a low saline content, which is less than 10,000 parts per million, with greater thickness than 1,500 feet. The Catahoula is depicted on the lower left. It is 2,000 feet in thickness and 3,000 to 5,000 parts per million of total dissolved solids. If you look at all of South Texas, this is an oasis of water, a huge oasis of water that doesn't exist anywhere else. So, if you really get down to the nuts and bolts, what will it cost the city to have anywhere from 30 million gallons a day to 50 million gallons a day as a function of pipe that extends either to Southwest Water Authority with reversal of the line, or an alternative would even be to go through the right-of-way from Celanese and even lay as much as a 60-inch line. We're talking about cost per unit. The unit cost here is 1,000 gallons. On the left, you see your hard costs: pipeline, treatment plant, well filled and disposal wells. Those facilities, utilizing the uniform cost modeling, Texas Water Development Board provides a uniform cost model, so there's a level playing field when people try to determine their costs in these type of projects. So the hard costs are about $440 million, utilizing that model from the Water Development Board, and the soft costs are about $121 million. I'm not breaking down pipe because we have a 10-minute limitation here, but when you get down using their model, it's about a $560 million project. We have costed out every element of this. We don't need steel pipe because of what I will explain later. Dr. Brownlow will explain in a little bit. But we don't need that. And we have a lot of efficiencies of scale here and relationships. And so I've met with Mr. Zanoni. I've met with Mr. Molly. We've looked at this cost. And there's about a 15% savings. And we can deliver, if you're looking for a number, we believe we can deliver water to the city of Corpus Christi for $6.50, 1,000 gallons. And that is a very economical number. It's a number that depends on the feasibility study. It depends on CPI when we finally get approval to move forward. But I think that you have to have a number to start with, and that is a reasonable number that we can justify. I'm going to turn this over to my partner, Dr. Brownlow. Dr. Brownlow is a very, very experienced geologist. He's the former chairman of the San Antonio River Authority and executive director of Evergreen Water District. And what you see here is 100% his concept. I'm a medical doctor. Occasionally I'll say, Daryl, I have a really good idea. Let's look at this. But I'd like you to meet Dr. Brownlow, and he has some thoughts to share with you.
Thank you, Dr. Mintz.
Thank you. If there's any time left, Doc. And the remote. Bear with me. We changed the order of the slides. One of the fascinating things about this project is the Eevee Ranch, the elevation of it. Located in Jim Hogg County near Hebronville, it has an elevation of approximately 500 feet. The significance of that is that over that 70 miles to Corpus or the 46 miles to Kingsville, you'd have 190 psi of positive head pressure. That's pretty remarkable, and I'll advance that discussion in a minute. The source itself, as Dr. Mintz indicated, is the Catahoula. This is a map of the ranch showing the database of information we have that's generating our models, 27 geophysical logs, 49 shallow groundwater wells. Importantly, there's no historical groundwater saltwater disposal on this ranch, which is very, very unusual in South Texas when you have brackish water supplies, that they've been soured with saltwater disposal from oil activity. Dr. Mintz mentioned this slide. The water district would be permitted through the Brush Country Groundwater District, which has a current pumping rule of 2.5 acre-feet per acre of land. We would be asking at the pertinent time 0.32 acre-feet per acre, so substantially below the permit requirement, almost a tenth, a third of an acre-foot. Also, I might point out that there is a significant export fees that would go to the Brush Country Groundwater District. We believe it would be a fantastic win for them as well. The water production facility would be on the ranch, the reverse osmosis plant on the Eevee Ranch. It would include additional 18 to 20 production wells, 3 or 4 injection wells, depending upon the feasibility study requirements. The pipeline itself, because of that elevation drop, it's so significant, we can utilize a variety of advantageous materials, HDPE, potentially even PVC, some of these things, which makes it cheaper and easier. This little model here I'll spend a second on demonstrates, and you have it in front of you, you can look at this, but the Eevee Ranch, if you have 28.5 million gallons a day going in on the Eevee Ranch, through that pipeline, it'll end up in Kingsville with 77 psi of positive pressure. That's quite remarkable. It actually would have enough pressure to drive itself all the way to the city, the Stevens water plant. So no booster pumps, think of that. But also remarkable is that there would be 35 million gallons of water in that pipeline under pressure. So in the event of an electrical disruption, you have water flowing. The pipeline route characteristics, rural brush country, soft. We think no rivers, no streams, or wetlands. The estimated cost, Michael went through that. The feasibility study we're proposing is laid out in front of you. It would consist of the city of Corpus, the port of Corpus Christi, and of course ourselves. The proposed schedule to do the initial feasibility study is about 12 months, and then a 6-month period to finalize investment decisions and supply agreements, et cetera. I might point out that the lease we have with the Eevee Ranch landowners is perpetual. It is perpetual, and so we have an option to lease it, and the lease would be perpetual. So we're open to opportunity for the city to purchase those elements of the option. So they could own this project if they so desired.
Thank you so much, sir. Appreciate it. Okay, next is Evangeline brackish groundwater project.
We're not doing questions yet.
Good morning, Mayor, City Council. My name is Ed Cross. I'm one of the general partners, thank you, of Evangeline Laguna. This is actually my third time to present to City Council. Evangeline Laguna is a partnership with the Welder family. The Welder family owns the property you see on the screen, the green. It is 23,000 acres of land. At our expense, we've spent over $4 million. We've drilled 2 test wells. They're shown on the map as PW1 and PW2. We have both the quantity and quality of the water in the Evangeline aquifer. Those wells exceeded our expectations of production, over 1.5 million gallons a day. And as I will show you in a minute, the quality of the water is potable. It is fresh water out of the ground. What's also important is that, and as you see on this map, you see the City of Sinton wells. Those are on the Bessie Welder Park. The Welder family donated that land to the city. There are 3 wells that are on that property. They have been in production for 40 years. The water is potable. It is fresh out of the ground. The City of Sinton has been drinking that water with a drop of chlorine to put it through its pipes for 40 years. Also, what's important, as you see on this side of Highway 77, is the Mary Rhodes pipeline. The Mary Rhodes pipeline, as opposed to other alternatives, we don't have to go very far to deliver water to you. One of the questions that we've been asked in the recent days is, could we deliver water to you quickly? The water that our well field is mostly on the 2 sides of I call it the tuning fork. So the wells would be located on the northern reaches of this property. We could actually drill wells. We could drill 3 or 4 wells and deliver water to you in 6 months into the Mary Rhodes pipeline. This is a little background. We, as a result of our test wells, we applied for and have received a permit from the San Patricio Groundwater Conservation District. We have a permit for 28,486 acre feet annually. That equals 25.4 million gallons a day. We have retained the same group that helped develop the City of San Antonio, the Vista Ridge pipeline, which we were a part of. That pipeline delivered 50 million gallons a day, delivers currently 50 million gallons a day of water to San Antonio. We deliver it from a well field that's 114 miles away. We built that pipeline in the well field privately. We delivered it on time and on budget. The same team, Pape Dawson Engineers and Garney, has completely engineered our project, completely costed it to deliver water either to the Mary Rhodes, to the Dressen Cutoff, which is the San Patricio pipeline that's immediately south of Sinton, or we could deliver the water all the way to the through the Mary Rhodes to the Owen Stevens plant. The Evangeline is part of the Gulf Coast Aquifer that, as it sounds, runs along the Gulf Coast. The Texas Water Development Board has done a study of this, and in San Patricio County alone, there's 51 million acre feet a year, acre feet stored. If there was no recharge, this is an aquifer that does recharge, it would last for between 292 years and 877 years. And let me remind you, we can pump 28,000 a year. So there's 51 million acre feet in the ground. We can pump 28,000 a year. Let's talk about water quality. So what you see on the screen in front of you, the 2 test wells we drilled were municipal caliber wells. They were 14 inches. We cased them in stainless steel. They were drilled to municipal standards. They are ready for production today. All you have to do is put pumps on them and pipes. Those 2 wells, the 2 metrics that you need to look for are TDS and chlorides. What you see there is the actual results from those two wells. Our TDS were 792 and 752. The chlorides were 269 and 217. Chlorides are salts. And so below that, you see the City of Sinton water supply. This is a 40-year history of their water from the exact same aquifer. And then you see below that the City of Corpus Christi treated water. You see the range of TDS, which actually exceeds the water that we have. It goes up to 810 TDS. And you see the range of chlorides, which also exceed our water. Texas Water Development Board water definition for fresh water is less than 1,000 TDS. It is incorrect to label Evangeline brackish. It is not brackish water. It is fresh water potable out of the ground. This is our team. Evangeline Laguna is myself, Bruce Hill, Fred Hamlet, and Hamlet Newsom. Our engineers, Gene Dawson and Kara Tackett. We have designed a well field. Steve Young is considered the #1 expert on the Gulf Coast aquifer. Based on our drilling and the science we have, we've already designed our well field. We've located our well sites. Steve Young has been our hydrologist to prepare all that. Locally, we use John Michael, and then many of you know James Dotson. I call him Old Man Water. He worked for the City of Corpus Christi and was the supply guru, I think, back in the 80s. I look forward to your questions.
Thank you, Mr. Cross.
Next is Barney Davis Seawater Project.
He's running away. Okay, good morning, Mayor and Council. My name is Stacy Barna, and I have with me also Ruben Munoz. Ruben and I both work with CDM Smith, and we were asked to take a look at the Barney Davis potential desalination plant that could be put at the power station. So we, first I'm going to walk you through the power plant itself, and then Ruben's going to tell you a little bit more about the potential for desalination at the power plant. So we did have an opportunity to go take a look at the power plant yesterday, which was fantastic to be able to see everything in person.
Stacy, I'm sorry, could you speak a little closer to the microphone? So we
Sure,
can hear you better?
absolutely.
Thank you.
So we did have an opportunity to go take a look at the power plant yesterday, which was fantastic. So we were able to go see all of this in person. The power plant itself was built in 1974. It's a large power plant with an intake that is permitted for up to 640 MGD. And you can, I don't know if I have a pointer here. Does this have a pointer on it? Basically, you can follow the flow with the red arrows there. So you can see where the intake would go in. You've got the power plant to the left of that. And after the power plant, you can see where there's a discharge into the cooling pond. And then from the cooling pond or reservoir, it's pretty darn large, you would have the discharge into Oso Bay on the top part of the picture there. So it's a 640 MGD intake that's permitted. The discharge, the cooling pond, is a 540 MGD discharge. And then right now, what they're actually utilizing is a 500 MGD, what they're actually using for cooling right now. So all that water that's going in is flowing out. Now, there was a study done by HDR back in 2022, 2023 timeframe, and that study did take a look at the potential to put a desalination plant that was about 20 MGD there. And the idea of that plant was to actually take the discharge and flow also, just following what it already is, into from the cooling pond back into to Oso Creek or Oso Bay that's in there. So the concern with that is if you go from 20 or even 25 MGD, that you would have to look at the salinity, the impacts on the salinity to the creek there and the impacts to the habitat surrounding there. I understand just in some conversations that part of the reasoning for looking at that sizing was maybe because it was comparing other options that were also currently being evaluated at that time, like Inner Harbor. In our review, we think that the potential is actually quite a bit larger for this particular site. You look at the amount of intake, the ability with the intake, the ability with the discharge, and there's an enormous amount of opportunity there to be able to actually have a desal plant that is much larger. So you can see to the left of the property there is King Ranch, just to help orient you, and to the right is more of that residential area. And closer to the intake, kind of to the south of that, you could see where there's the potential to actually have property. There's open property there where you could possibly put a plant. And if not there, then maybe there'd be some ability to work with King Ranch. So let me see, what else do I want to mention? If you look at the overall site there, which is light blue lines that border it, it's about a 2,000 acre property. That cooling pond is about 1,100 acres of that, and a lot of that is for temperature, because the water does come out very warm, and so they have to have it cool down before they can discharge it into Oso Creek. Let me see, I think that was the main part of what I wanted to say about that, and I'm going to have Ruben, well, these are just a few pictures from yesterday, so you can see here the intake from the Laguna Madre up on the top left, and then the discharge to cooling pond on the top right, and then the discharge to Oso Creek. And if I had zoomed in a little bit, you'd actually see right at the bottom there was a bunch of fishermen out there, so that's why we think that part's important, to make sure that you take a look at the salinity there. Ruben?
Yes. Thank you, Stacy. Thank you very much. So I'm going to do a very high-level overview of the process, how we can utilize this site. So how you see in the diagram, this is a co-location. A co-location is meaning to take advantage of the existing power plant, and this has been applied already in the U.S. We have already a desalination plant in Tampa Bay that operates in this way, taking the water from the cooling system. It's a 25 MGD facility operating more than 10 years. And also in California, we have Carlsbad that is also operating the same concept, taking the water from the cooling sites and also taking advantage of the co-location. So the major advantage of the co-location, as you see in the diagram, is that we don't need to build any additional intake and outfall system because it's already there. So it's already an impacted area. They already have permits. In terms of capacity, for instance, the intake of Barney Davis have a maximum intake of 640 MGD. It's a massive intake. So the advantage is that we will not need to affect with a new intake area. We are not going to affect the pigment and treatment because it's already an operating plant. So in the cooling pond, in the cooling discharge, the discharge permit is around 540 MGD. So again, a massive flow. So we're taking this portion of flow for doing the desalination process. And then we are going to blend in the discharge of the RO plant with this massive 540 MGD of the discharge. So the dilution, and we do some calculation with different capacity, 10 MGD, 20, 25. So we get some estimation of what will be the salinity increase on the discharge. In case we need to go for a bigger capacity, for instance, 100 MGD, then we think the option to go to the Gulf. This again more increase the cost of the plant of the solution, but we can get more increase in capacity. So that's why you see on the right side the discharge option could be Oso Creek, one of the options, and the other option could be the Gulf of to the Gulf of, and this is more, let's say, 7 miles more or less of pipeline that, as I mentioned earlier, might increase the cost, but maybe is a solution for any concern related to environmental impact. So, as I said earlier, to minimize the impact, we have this 540 MGD of discharge, which allow us to dilute the brine coming from the plant, and we have also the advantage that warming water will reduce the cost of the desalination. I'm going to talk about in the next slide. So a little bit of summary of the advantage of the co-location, and then any detailed question we can discuss in the question and answer. So the first advantage is the significant cost reduction. So we don't need to build any intake, any discharge, so we can take advantage of the Barney Davis infrastructure. The salinity, as you know, the river osmosis process concentrate the brine, let's say 1.8 or 2 times. So this salinity is reduced with blending with the water coming from the Barney Davis. So this massive flow, usually is not available in many other locations. It's only where you have a collocation. Also, optimize energy consumption. This is very technical, but when you have a high temperature water, the membrane permeability is increased, so you will need less pressure, so therefore less energy. So it's an optimized solution from the point of view of energy consumption. So because it's reduced the OPEX and energy, is 50% of the O&M cost. The other advantage in terms of capital cost is the connection to the power. We have very large, more than 1,000 mega of substation there, so it's very easy to connect or to do all the connection to the power, and this reduces significantly also the cost. In other plant locations, you will need to do a substation, transformer, transmission line, and this also increase the cost of the plant. So in this case, you don't need to do this. In addition, also, in terms of the power price usually when you are located in a generation site, you usually depend on the tariff composition, but you don't need to pay the transmission charge. So this is another advantage to be located just in the generation site. Other advantage is that there is a very close transmission line, 42-inch. That's where we can send the product water there, so that we don't need to build any expensive pipeline connection, which in other side you might need to increase, significant the cost of the water because you need to build transmission lines. So in general, since all of these concepts, we will have in this site taking advantage of the collocation, very significant low cost for the O&M and low cost for the capital of the desalination plant. And also the potential. So the potential, if we want to go for more than 25 MGD or for 100 MGD, then of course we need to take a look on the permit, build a larger pipeline to connect, and also the option to send the brine to the outflow to the Gulf. This is, for your sake.
Okay. Thank you. Okay, so, and this is just to wrap it up a little bit more. So as I mentioned, the HDR study was done, but it seemed to be limited. Okay, so thank you. We appreciate it.
Thank you very much. We appreciate it.
Perfect.
Next is the Port of Corpus Christi Harbor Island permit.
Good morning, Mayor, Council members. Sarah Garza. I am the Director of Environmental Planning and Compliance for the Port of Corpus Christi. And this morning, I'm going to give you an update on where we stand with the permitting for Harbor Island and review some of the details of the plant as we have permitted it. So in terms of what is pending for Harbor Island, we do have a discharge permit, 50 million gallons a day production in the Corpus Christi Ship Channel. That is a permit that we have in hand. We have a water rights permit application pending currently with the TCEQ. That permit is under technical review. We have a lease and easement that has been approved and signed off by our CEO, Kent Britton, and awaiting signature by the GLO. We just submitted our Section 10, Section 404 permit to the Army Corps of Engineers. We actually submitted that through the Fast 41 process, which is a federal oversight and accountability arm of the federal government, which provides accountability to the permitting process. We will be submitting the discharge permit for a discharge in the Gulf of Mexico for 100 million gallon a day discharge. Not the produced water is 100 million gallons a day. The discharge will be a bit more than that, but that is for discharge in the Gulf of Mexico. We anticipate putting that into the TCEQ in March. We did have a pre-application meeting with TCEQ staff earlier this week. And then once we have the discharge underway, we'll look at an amendment to the easement with the GLO for that discharge offshore. When we got the team together to talk about permitting the remaining elements of the desalination plant, there were a couple of things that we represented both publicly and to the Port Commission that we were going to uphold through that process, and that is to continue to have database decision-making. We're going to permit with as much optionality as possible, so not limit anything at this point, and then of course uphold our environmental policy, which you've probably heard many of our members talk about 6 different precepts that are each have targets associated with them. So all of that carries through the permitting process. This is a high-level overview of the facility and the intake and discharge in the Gulf of Mexico. So Harbor Island is located on the Corpus Christi ship channel between Aransas Pass and Port Aransas. And we have proposed using the route that Blue Water Texas Terminal, if you are familiar with that project, it's a single point mooring system that is associated with loading crude on VLCCs. They had an EIS in process. There's actually a draft EIS out there. It hasn't been finalized, but with that EIS, there's a lot of information that has been already accumulated. So that route provided the most information for us in terms of environmental studies and things like that. And as it turns out, provided the most efficient routing. So the intake is located 1.3 miles off of San Jose Island, following that Blue Water Texas Terminal pipeline route. And then the discharge is half a mile beyond that. And so both of those were evaluated through engineering conceptual design. And then we also have the facility laid out. What you see there on Harbor Island is the 100 million gallon a day facility, so 2 50 million gallon a day mirror facilities. With the project, we have avoided or minimized all the impacts for potential impacts to the environment. So if you look at the facility there on Harbor Island, it avoids all jurisdictional wetlands. So you can see that there are yellow areas. Those are the jurisdictional wetlands. It does look like some of the facility crosses over those jurisdictional wetlands, but in fact it goes underneath, and so we're able to avoid any impacts. The location of the intake and the discharge off of Harbor Island there does cross 2 federal channels. So part of that coordination is with the Corps of Engineers. When you go under federal infrastructure, you are required to be 50 feet underneath of the federal infrastructure. So that puts us at about 65 feet below the water. When you look at that, there's some options for construction, but as we evaluated what are the potential options, the most efficient was to use the tunnel boring machine. And so the tunnel boring machine would enter on Harbor Island and not come out until the intake and the discharge out in the Gulf of Mexico at the 35 and 37 foot contours respectively. So you can see there the how it goes down and across, matches those distance offsets that were required for, and then with that avoids any impacts on San Jose Island. San Jose Island is of course an environmentally sensitive area, and so all of that is accomplished through that tunnel boring machine. When you get out into the Gulf of Mexico, the intake structure is set right down on the pipe that comes up, and there are 5 velocity caps that are on that structure. Each of the velocity caps work to slow the water down to ½ a foot per second, which changes the, makes a change in the water conditions so that fish will swim away from it. In addition, we have proposed the placement of 3-inch bar screens on those velocity caps so that if anything doesn't swim away, if it's larger than 3 inches, it'll be prevented from going in there. If there's anything that's smaller than 3 inches gets in there, we do have a marine life return system back on Harbor Island. So anything that does make it into that pipe, it's gravity fed all the way back to Harbor Island. It'll be lifted out of the water on these screens and put back into Aransas Channel. In addition, the intake structure is 10 feet, proposed to 5 to 10 feet off of the bottom. That's to avoid impacts to the benthic layer. In talking with HRI, there's a nephloid layer that generally ranges between 10 and 12 feet, so we're looking more towards the 10 feet off of the bottom. You don't want that biomass in your filter systems anyway, so it's a good addition to add that additional height. The discharge, we have modeled and determined that half a mile will prevent any influence into the intake structure itself. And so it follows that same route, but then is a half mile further. Again, the discharge follows the same route in terms of construction methodology and going down 50 feet below the federal permitting, federal infrastructure, the Rances Channel and the Lydian Channel. And then the diffuser itself out in the Gulf of Mexico does come up at the 37-foot contour. The diffuser is a 500-foot long barrel. It has 2 ports sticking off of it for a total of 25 ports across that 500 foot. And what it does is diffuses that brine into the water column so that we can meet a 2 points per thousand at 100 meters from the discharge. This picture right here just gives you an overview of what we have proposed for the distribution system. The distribution system represents basically putting water both into the Nueces County Water District. There's a 16-inch line that comes off of Harbor Island, and then also going back and connecting to San Patricio Municipal Water District. This representation here is only the representation that is required for the core permit. We did not have to represent going back to all the way to that wherever we would connect into the San Patricio Municipal District infrastructure, because that would be infrastructure improvements done by others. So for the Corps of Engineer permit, this is what's represented. So that's why that doesn't show the full length of where we would go. This right-of-way is right-of-way that is owned by the Port of Corpus Christi, and so another reason for including it in our permit. This slide just presents an overview of how we have avoided all environmental impacts. We do have some temporary impacts that are associated with the installation of that distribution line in the right-of-way, but those will be restored once construction is complete. And then, of course, you have minimal impacts associated with an intake and a discharge. Those can't be 100% avoided, and so we've minimized those using best available technology. Otherwise, we've avoided all environmental impacts. And that is an update on our permitting and where we stand with the facility itself.
Thank you very much. Next, we have the solar panel installation group, and they will be presenting virtually. Sir, are you on the line?
Yes. Should I share my screen? Is that the best?
Excellent. Okay, you ready to begin?
Yes, we're ready to begin.
Right.
I'll tell you when we need to change slides. Amazing. Well, it's great to present to you all today. My name is Tate Tusing, representing Noria Energy, and I'm here with my colleagues Alex and Cavi. A little background on floating solar. It's exactly as it sounds, and as you can see in the picture, it's just large-scale floating arrays that float atop the water that passively generate electricity while also preserving quite a bit of water through evaporation reductions and limiting algae populations and blooms, dramatically improving the water body. We like to say that it's delightfully boring because each module is highly scalable and can plug in together to create large systems for maximum benefit. So next slide. You can go one more slide. So a little background about Noria Energy and who we are. Floating solar is fairly new in the US, but it has a fairly established market globally. So in 2018, when the company was founded, we were one of the first floating solar developers in the US, and therefore we were specializing in largest of their kind and very complex systems in both the US and Latin America. And we do that alongside our research and development team who is developing technologies to further advance the industry. I should also mention we're backed by Greenbacker Capital, who's one of the largest renewable energy financiers in the country, who not only invest in Noria as a company, but also serve to own and operate many of our projects. So next slide. So Noria Energy is able to perform all tasks from inception to operation of a floating solar system. So for the city, we would recommend starting with a feasibility study, which will take about 6 months and would give the city everything it would need to make an investment decision around floating solar. We would then also perform the development services, which in Texas's highly deregulated market would be very fast. And then we could perform the installation and financing of the project, which, based on how segmented or modular each of these systems are, is able to be rapidly deployed. We have a number of customers, both that are cities, water agencies, and heavy water users in heavy industry spaces that we'd be happy to give you contacts for recommendations. Next slide. So just to give a little more in depth about what floating solar is and how it works, it's essentially just solar panels that rest on high-density polyethylene floats that are food grade and, of course, water safe. They're used in almost all water piping applications. The array itself is anchored either to the bottom of the water body or to the shore. And then globally, there's about 3 gigawatts installed. And in the US, it's rapidly growing, though right now there's only about 50 megawatts installed in the US. One of the tremendous benefits is that deploying solar panels on the water do not take up any developable land space, and it's able to be a dual-use entity for generating electricity and preserving water. So next slide. So I'll go through these few case studies very quickly to get to the meat and the potatoes around water quality. But this is one of our systems installed in Colombia. It was on a hydroelectric facility and required very complex engineering to complete. It started with a feasibility study where we identified 120-foot elevation changes in the water body itself, which we were able to engineer around, as well complex stakeholder and investment entities just with local governments, the Utility Commission of Colombia, as well as many other stakeholders. So next slide. This is our flagship project in Healdsburg, California. The 4.8 megawatt system when it's operating at its peak capacity supplies over half of the energy that the city requires. This system is atop their water treatment facility, and this relatively small system is able to preserve 9.5 million gallons of water annually through evaporation reduction, all while supplying renewable energy to the city. Next slide. So I'll pass off to my colleague Alex, who will go into the water quality benefits and evaporation savings more specifically.
Yeah, great. Thanks, Tate. So my name is Alex Cagle. I've been with Noria for about 1.5 years, but I've been in floating solar for about 7, having completed a PhD on the water quality and environmental benefits of floating solar prior to being at Noria. And so first, we'll talk about the main reason we're presenting here, and that's evaporation. So this may not be new information to those at this meeting, but Lake Corpus Christi, which is where we're proposing the floating solar, alone loses anywhere between 65 to 85 million gallons a day due to evaporation. And so as drought conditions continue to intensify potentially, these evaporative savings can rise significantly. So next slide, please. And as drought conditions increase, as temperatures increase, and as reservoir levels potentially drop, these create a breeding environment for harmful algal blooms and cyanobacteria, which have a suite of issues for the lake, Algal blooms create unsafe recreational opportunities by releasing cyanotoxins into the water body. These cyanotoxins disrupt ecosystem equilibriums and alter the water chemistry in negative ways, just really creating a host of both physical, chemical, and biological issues for Lake Corpus Christi. And so if we go to the next slide, please. Great. And so this is kind of the bulk of this. In addition to major evaporative losses from the lake, this is where floating solar kind of comes in. So not only as a source of additional revenue for the city by providing renewable energy, but also to directly address the evaporative and water quality issues associated with the lake. So beneath an FPV installation, the shading and lack of surface wind conditions can reduce evaporation anywhere from 50 to 80%, depending on the microclimatic conditions and other associated factors of the solar array itself. And so by deploying even a small FPV installation that covers a small percentage of Lake Corpus Christi, millions of gallons of water can be saved annually. And so to arrive at an exact evaporative estimate, a more detailed feasibility study is necessary to take into account some of the major factors that would impact evaporation. So these include typical wind dynamics, some proposed FPV size information and location on the reservoir, and then also some other site-specific components. Another fun fact is that the convective cooling of the water under the panels actually increases production by roughly 10%. So there's both water and energy benefits. The shading also reduces the conditions for the harmful algal growth that was mentioned earlier and cyanobacteria. So surface water temperatures are reduced below floating solar installations, and they also reduce stratification, or the layering of different temperatured waters. And so this, as you can see on the right, this figure 1 shows that as you increase the floating solar coverage, you decrease chlorophyll A, which is just used here as a proxy of overall biological activity. And so this is where NORIA really comes in as an industry leader in addressing water quality concerns, not just solar development. So we have a suite of PhD researchers and engineers that have created novel both water sensing applications to inform the city of water quality in real time, what's going on beneath the array, and also the ability to power water treatment technologies from the floating solar array itself without using any energy that would be deployed to the grid. And so in this way, NORIA is uniquely aligned to prevent evaporative losses and work with the city on the waterfront, and also provide the energy saving benefits. And then with that, I'll pass it over to Tate for some proposed next steps.
Yeah, so next slide, please. Great. So ultimately what we see as the optimal project for Corpus Christi is a front-of-the-meter solar system on Lake Corpus Christi, where we would inject energy into the grid, and then we would actually pay Corpus Christi to lease the lake itself, all while that solar system is preventing evaporation. So this is not only going to serve as a water positive feature for the city, but also serve as a revenue source for the city as well. So we would propose doing a feasibility study, which I mentioned would take likely about 6 months to analyze all the environmental.
Sir, your time is up. Thank you so much for your presentation.
Okay.
Next, we have the Nueces River Authority desalination project.
Thank you, Mayor and members of council. It's good to be here today. My name is John Byram. I'm Executive Director of the Nueces River Authority. We want to tell you about a little bit about the authority. Our enabling legislation was issued in 1935 by the state legislature, and we were to preserve, protect, and develop water resources, flood control, irrigation, navigation, water supply, wastewater treatment, water quality control, recreation, parks and recreation, solid waste, and we've also been able to help with financing and receive grants. This year we will be 90 years old. Not me, but the authority will be 90 years old. I'm nearing 90 myself, but anyway, that's a big deal for us. We've been helping people throughout the basin for quite some time, and I'd like to remind Council that we have helped you and worked with you and partnered with you on the Mary Rhodes pipeline. And I'm very proud of that and be able to say that. And we also partnered with you on the Choke Canyon Reservoir, where we still own 20% of the reservoir, and we have an agreement where you lease that from us annually, and thank you for that. So those are successful projects we've helped with in the past. There's big needs in water projected basins throughout the basin and beyond through 2030 and 2070. Don't get hung up on those numbers because those are bigger than just the basin itself, but those are other areas that we would like to help with and we've been asked to help with. And that's one of the things about our enabling legislation is morning, Peter, that is one of the things about our enabling legislation is that if we are asked, we can basically work anywhere in Texas and help people out with these things upon request. So the deficits that I showed there do not reflect, they're just municipal deficits. They're taking from areas in the state water plan, and they do not reflect any new industry because the Texas Water Development Board won't allow you to do that. So we've had discussion with legislatures. We've looked at the Texas Water Plan, and of course we help with the Region N. We are the political sponsor for the Region N water planning group here. And we saw that there was a need. We saw that there was a need beyond just the coastal bend. You folks are taking care of your needs, and we're tickled to help you with that and tickled to support you with that. What we see is a need beyond the CCN of the Corpus Christi, Certificate of Need and Necessity of the Corpus Christi area. And we want to help them. The larger you build, the economies to scale. And so we started looking at that. We started talking to legislators, and we requested from the port, we proposed to them that they assign us their permits once they're done, and that we use that site to serve the bigger region, the larger region of South Texas. We have asked for that. We're in negotiations with the port on that at this time. We wanted to develop a P3 partnership, a public-private partnership. Well, why is that important? I think that's very important because, one, they can fund the construction, the design and construction of the plant. The second thing that's equally as important is that the heart and soul of a desal facility is the membrane, the membranes. And these people buy the membranes from manufacturers that tell you that you can get 5 or 6 years out of the operations of that. We've talked to several companies already that are operating plants today around the world, seawater desalination plants today, that have 12 years on their membranes and they're still in service. That equals a lower cost of operation. And I think that's really super important to us. You know, we developed the seawater desalination technology here in the United States. They use it overseas now more than we do. When I went to Cairo, Egypt several years ago, we drank seawater desal from their facility. So what we would want to do is partner with a private company to design and build the plant. We would take that water and we would move it up into South Texas through, we would propose to use the I-37 corridor to do that. We'll see how that works out. But we need to take that into South Texas to satisfy water needs. The other thing that I want to talk about is we're going, the port is going deep water in their discharge. I think that's super important because we've talked to folks that are operating desal plants and have operated them for over 25 years, and there is absolutely zero impact to the environment. So it can be done safely, it can be done without harm to the environment. So that's important too. So where we are now, we are looking for off-takers. We are looking for municipal governments and others that need water up in the basin. We're talking to them about that. We have told them it's a first come, first served. There's up to 100 MGD that can be sold, million gallons per day that can be sold. So we don't anticipate exceeding that for some time. So we're looking at a reservation fee, and I put this in per 1,000 gallons for other people, but I like to talk in acre feet. So it's $24.48 an acre feet for municipal governments that need water, okay? So what this does is that's a really cheap fee, and I understand that. But what that's going to do for us, it's going to allow us to tell our partner, Black & Veatch, which Mr. Aye's in the, wave your hand, Joe. There he is. He's a project manager from Black & Veatch that is our project advisor. It's going to tell us what to tell him to take the water to. In other words, we will know a little bit about the conveyance system after we go through this process. You know, you can ask people, yeah, I'm interested, but until they pay, you really don't know that they're buying in. So we're trying to go through that steps now. We've just had a few initial meetings with that. So we can define the final size of our plant, initial plant, and the conveyance system from it. With that information, then we'll take the next steps to finalize the plant capacity and the pipeline plan. And then we'll develop the pricing structure for our customers. Now, I want to talk a little bit about that pricing structure. We have what I'm going to call a Class 6 estimate. There's 5 levels of estimates. The Texas Water Development Board criteria that was talked about by one of the gentlemen before me, or could be the lady before me, I'm not sure. But someone discussed the estimating. The TWDB does one that's got a whole lot of contingencies built in because it's from 50,000 feet, if you will. And if you look at that, then they're telling us that it's about $12 per thousand to build this facility and to sell water from this facility. That's what we need to retire the debt and operate the facility. The worldwide average on seawater desal is between $10 and $13 per gallon, okay? So we feel comfortable with the $12. If you're going to ask me how much we're going to finally charge, I don't know. I do not know at this time. We've got to get further into the project, and we can discuss that. So that is my presentation. That's what we're planning to do. We're asking people now if they want to buy in, if they want to buy. Once we get to 100 million gallons, obviously we're done, you know, for at least an initial period of time before we would want to come back and expand the plant. I think the expansion in the current plan that's introduced into the Senate, right now you're looking at about 450 million gallons is what they are introducing this plant to be, the Harbor Island plant. There's another one up in the Freeport area somewhere up in there. That would be 450, and then there's a 200 million gallon a day plant also proposed for the Brownsville area. Thank you very much.
Thank you very much, sir. So now we'll begin the council member question and answer period. So council members, you can ask questions of any of the other candidate water supply project representatives who are here. Each of you has up to 10 minutes to ask your questions and hear the responses. And I'm going to call each of you first, each district council member first in order. Then at-large council members Vaughn, Scott, and Barrera, and then we'll end with the mayor. So that would mean you begin. Councilmember Roy, do you have questions for all the candidates, or I guess just call them up as you have questions?
I have.
Oh.
Okay, which candidate, which project do you have questions for?
Right now I have questions for the Evangeline groundwater project and then the Nueces River Authority.
Okay, very good. All right, so you want to Evangeline? Thank you, sir. Okay, and the timer.
Thank you for your presentation. My question is pretty simple. I know that in the past we've worked with you over a period of time with your organization over the last 2 years that I can remember, and I believe when I was on council before we also worked together. And at that time I felt like the negotiations were going well. And then at some point, we received notification that you were no longer, your organization was no longer interested in continuing to work with us. And I just wanted to kind of know that what happened, and if you could, that led to those termination of the negotiations, and then can you tell me what's changed?
Yes, sir. I don't want to rehash those negotiations. We weren't able to reach agreement on business points, and that happens in negotiations. We have been contacted by a number of parties. You're in a bad drought, and there's a lot of demand for our water. The biggest change, Councilman, is that in those negotiations that were terminated last summer, we were talking about entering into a 30-year lease with the city with renewal. We are now willing to sell the water rights in the ground, convey a fee simple title to the water rights. So that's the biggest change since last summer.
Okay, thank you. My next question was for the Nueces River Authority. Sir, you mentioned that you're looking at starting at 100 million MGD, but maybe having the possibility of ramping up to 450 million MGD. So in your design and your cost estimate and the things when you talked about the rate model that was around $12, did you take into consideration, I'm going to make the assumption and tell me otherwise, is that if you're going to look at expanding to a 450 MGD plant or facility, that when you lay your pipe, you're going to have to make sure that you incorporate that pipe size with the largest expansion that you intend for that facility. Can you tell me, was that cost structure based on looking at the amount that it would cost at 450 MGD?
No, sir, it was not. That had a 60-inch line coming out of there, and we're looking at putting 144 in initially. And the way that we would do that is we have been talking with the legislators about coming up with state participation. And what that would look like is an oversizing agreement, which I'm sure the city of Corpus Christi has. So they would participate with us in the delta of cost between the 60 and the 144. And as we had customers tie on, then we could retire that debt at a later date. So that's the way that's being looked at.
So again, my question is kind of in terms of the, when you're out there actually designing that model, because if I understand it right, the cost of being able to lay that pipe in anticipation of 400 MGD is significantly greater than 60 or 100. And so I'm assuming that you wouldn't want to go through and you'd either have to add another pipeline, right, alongside, or you'd have to do something to accommodate to be able to expand. And you made the comment that the state, right, was basically looking at the 450 MGD.
That's under consideration at this point in time, yes, sir. So it's also under consideration to participate in the initial construction so that we don't have to retire debt based on the current ratepayers, based on the 100 MGD. We could retire debt at a later date as we grow.
Okay, so I guess, again, where I was really thinking, and maybe I'm off on this, but when you look at what you quoted at $12, based on the model, based on the pipeline that's in existence, if you were to increase that pipeline, you're going to be, I think the ratepayers would pay more than $12. Is that correct?
No, sir. Not if what is being introduced in the legislators, the Senate, not if that passes. If that passes, then the $12 would be the upper end.
What if it doesn't?
Well, then we have to regroup.
Okay, thank you. That's all I had.
Thank you.
Thank you, Councilmember Roy. Next, we have Councilmember Campos. Do you have questions for all, or you do? Okay.
All right. I kind of wrote down some minimal questions that I thought if we could make sure that we have. I wanted the environmental costs, the timeline, the financial costs, the permits, the quality, and how many gallons that we would receive. So as each presentation was being presented, I wrote down what I think I have. But so the Catahoula water environmental costs was minimal, right? Okay. Timeline that I have, I just want to make sure that I have this. Okay, if you don't mind, timeline is 18 months?
No. It would, we can expedite the pipe, but it's going to take 16 to 18 months to lay pipe. So you're going to have feasibility study, designing the system.
And that was the permits.
So I would say 30 months, 24 to 30 months.
30 months?
Yes.
Okay. And as far as permits is concerned, you still would need to obtain permits?
Well, it's a great question because it is water coming from a groundwater district, the Brush Country Groundwater Conservation District. And at the appropriate time, we would apply for those permits. The testing could be done without the need for permits because the testing and the feasibility study are necessary to define the amount of water that we would be able to produce, how many wells that we'd drill, those sort of things. So that information would be garnered during this 12-month initial feasibility study period, at which time we would go forward with the permitting process with the groundwater district, presenting models. And there's not just the groundwater production permit, there is an export permit, because when you take water out of a groundwater district and send it outside, there is a process of permitting the exporting of the water.
So initially, it would be at least 12 months to at least find out if you're going to need any more additional permits. Is that correct?
No, I think that's the permits that we would need are the permits necessary to remove the water. It's very similar to the Evangeline Laguna project in that sense. They have a groundwater pumping permit. They would need an export permit. We would need a groundwater pumping permit. We would need an export permit.
Okay. And actually, well, that would be then, and then I guess that would be the next one, Evangeline. I didn't have the environmental costs, which I think should be minimal, right? I didn't.
None.
Okay, good. And the timeline that you had was 6 months on your project.
No, ma'am.
What was it? That's what I wrote down.
Depends on how much water you need and where you need it. So in our negotiations last summer with the city, we were delivering water either at the Dress and Cutoff or all the way to the Owen Stevens. And we committed to 28 to 30 months after contract execution to deliver that. That amount of time allows for the drilling of the well field, which is 23 wells, the creation of a gathering system, central pump station, the pipeline around Sinton to Dressen. So it was 28 to 30 months. What I mentioned on 6 months, this is somewhat akin to what y'all are doing on the Nueces River. In an emergency, and you're in an emergency, we could drill several wells on the northeast corner of the ranch and pump it directly into the Mary Rhodes right there.
Okay.
Much smaller project.
Okay, so that's why I was like, wow, 6 months. I need to ask a little bit more about that. And the financial costs, I didn't have.
Again, how much water, where do you want it?
All right.
And by the way, that also depends on who finances it. So if it's public sector financing, there's an interest rate. If it's private sector financing, today the private sector financing is roughly double what the public sector is.
Repeat that again?
So I'm going to, Peter, y'all are AA plus?
We're in the high grade category.
Yeah, so your rate today is 4%?
The last issuance was less than that.
Yeah.
Less than 4%.
Your borrowing rate is 3.5% to 4%. My rate will be 8% to 10%.
Okay.
So if I finance it, that's embedded in my cost. If it's a public sector financing, you cut that cost in half.
All right.
Does that help?
Yes, it does. How much time do I have? 5? Okay, good. Okay, there's so many, but I still want to get to the first, Noria. This is the only, do we have Noria online?
Yes.
Okay, great. Of all these projects, you're the only one that's actually has a way to actually bring in money instead of costing the city money. So what would be permits for your project? What is it that I know Texas is very lax, so what do you foresee in the permits for your project as a issue?
Yeah, so permits will not be a huge issue. Largely, they're at the federal level, environmental impact reports and things like that. I'm glad that you called out that we're the only one that would generate revenue for the city. But usually, I mean, our projects in California and in New Jersey that are highly regulated are developed, and the permits take about 12 months. So to give you that timeline,
okay,
it's going to be significantly reduced in Texas.
Thank you for reaffirming that. The other is, I've heard complaints about, we can't put these solar panels in the water because it's going to affect fishing. You mentioned that, and when I first brought up this project, it was like, but we can't do that. It's going to cost too much. But in reality, the cost would be absorbed by your company. Is that correct?
Yeah, well, I'll speak to the commercial side of it, and I'll hand it to Alex for the water quality stuff. Yeah, so what we would plan to do is sell the energy into the wholesale market and then pay a lease rate to the city. So it would be an investment for us and for the city. So that's how the commercial structure would work. Does that make sense?
Okay. And again, what the timeline do you see saving our water, our evaporation? What would you see?
For the timeline for the project, feasibility, we expect to take about 6 months, development another 12 months, and then construction, it's very fast, between 3 and 6 months. So on the high end, we think 2 years, and the system could be in operation, and then that evaporation savings realized.
Okay. But again, you would actually be making money for the city, not costing us for saving the water that we currently have right now, which is we keep going lower and lower. So, okay, I think that's all the questions that I have for Noria. All right, let me see if I can go back to, well, I must say, I guess the Port of Corpus Christi, I had check marks, really great for the environmental, I mean, as far as, and it looks like y'all had most of the permits. Let me see. I think that's all for now.
All right, thank you, Councilmember Campos. Councilmember Cantu, he's ill. He said he's going to go ahead and waive his question and answer period. His voice isn't up to par right now.
He's going to give it to me.
Nice try. Okay, next we have, so that would mean Councilmember Paxton goes next. Yes, ma'am.
I have 2 minutes left. I do have one more if I could ask. Barney Davis.
Is that okay, Mayor? Go ahead. Okay.
Thank you. Appreciate that. On the Barney Davis, okay, the financial costs, you didn't mention that either.
So I think the financial cost, really, the next step would be doing further feasibility on the options, because really the 2 options that we'd be looking at would, one, be do you do a smaller plant that would possibly just go back to Oso Creek, or do you want to do a larger plant, in which case your discharge is probably going out to the Gulf. So the cost would be the next step, but you'd have to do the feasibility to look at really all of your options to see which way the city would prefer to go with it.
And the biggest for me would be the environmental cost. What would that entail? What would that?
Do you want to talk about that?
Yeah, the environmental cost, I think, will be several components. So the first components is to do the survey, the baseline of the Oso Creek, the salinity, do identification of especially endangered in that area, do toxicity tests if it's required, stakeholder engagement. So it will be a full list of, during the evaluation phase of that cost. And also during the project, if we want to, let's say, as Stacy mentioned, go to the Gulf, it will be significant cost. So we can also be be allocated as environmental cost, right? To prevent any damage, you can go to the Gulf.
Right.
But this will increase significantly also the tariff, right? So this component environmental will be allocated in many cost items during the project phase.
Okay, I guess we'll be able to submit our written questions to each company. Okay, all right.
Yes, ma'am.
All right, thank you so much.
Okay, so that means Councilmember Paxson, you are next.
Thank you, Mayor. I have a quick question for the Eevee Ranch project, if I can. My colleagues did ask some other questions that answered those. At one point in the slide, when you were going over the TDS counts for the project, I heard 5,000 mentioned, and I think that it went a little fast for me. Could you just circle back real quick on that?
Well, I think the TDS, based upon the geophysical information we have from the Water Development Board reports for that section of the Eevee Ranch at depth, would range between 1,000 and 5,000 TDS. So until we develop and define that specifically, it'll be in that range between 1,000. It could be 2,500, it could be 1,500, it could be as high as 5,000. But based upon the geophysical information we have, we believe it's somewhere between 1,000 and 5,000 milligrams per liter TDS. It would leave the ranch, of course, through at potable standards.
Okay, that answered that. Thank you guys so much. I do have also a question for the Evangeline project. You're getting all the questions, thank you.
I'm getting my steps in today.
Yes. So to piggyback off of what Councilwoman Campos asked about the differentiation between 6 months and the 28 to 30 months, my question would be, if we were to go the route for emergency water access, what would be the capacity that we could obtain in that the well that would go straight over to Mary Rhodes pipeline, kind of circumventing that long-term solution because we are in a water emergency type situation? What would be that capacity versus the 28 to 30 months? You did mention that there's option for other entities to also access this water. And I guess my question is, what would the potential for Corpus Christi to access total?
I'll answer that question first. So the total capacity is 25 million gallons a day. And in our previous negotiations, Corpus was taking 100% of that water. Your question about the emergency, each well will pump comfortably about 1.5 million gallons a day. Right now, the constraints that you're facing and we would face is getting a driller out there and how fast they could drill wells. And can you get more than one crew? The constraints are physical of getting crews out and then ordering pumps. Everything electrical right now is back ordered in America. And so pumps, electrical switchgear, anything and everything electrical is tight, tough, expensive. So if this was of interest to the city, we'd move heaven and earth to make it happen because you're in an emergency.
So if it was something that we were to identify as a priority to try to move that through quickly, I think you said 2 wells? What would be our potential, you know?
Yeah. So can you put my deck back up on the screen and go to the very first slide, the map?
Control room, did you hear that request?
Big ass there, fella. They're racing back to the computer.
Yeah, me and technology are occasional friends.
We do have it in front of us, Mr. Cross.
Oh, okay.
In
So
the
let
spirit
me
of time,
describe. So it's a tuning fork. I call it a tuning fork. The ranch is a big U.
Yes.
And our well field design is 23 wells to produce the maximum 25.4 million gallons. So roughly half of them are on one side of the ranch, half of them on the other. And so the half that's on the east side, this is the northeast corner of the ranch, that's where the Mary Rhodes pipeline is. So this isn't a commitment, this is me trying to answer your question. There's roughly 12 wells, and if we drill them fast and we're able to get the pump gear and connect them over the Mary Rhodes, we could probably deliver 15 million gallons a day. By the way, you're catching me completely unprepared for this question. My engineer said we could drill wells quickly, bring that up today, and I'll blame it on them without naming names.
We wouldn't be in a situation, though, that we would have to drill one to completion and then the next, and that we could just start on that if we moved forward, and I'm speaking very hypothetically.
Yeah.
We wouldn't have to wait per,
We have our permits.
yeah, okay, perfect.
And so we have our permits, we know where the water is, we know where the sites are, it's getting the driller.
Thank you so much for your answers. My next questions would be for the Barney Davis project. Okay, thank you guys so much for your presentation. I understand that the power plant's already in operation, and you listed some pretty substantial numbers that are moving in water volume presently. Being that it involves the Oso Creek, that's a really valuable area for the city. I was just in conversations this morning looking at, ideas to really incorporate that natural scape footprint into branding for the city. So my questions are going to be centered around how to very, very responsibly steward care for that area. You did mention that there's capacity for this project to go out into the Gulf. One of my questions is, what would be the difference in what you're already discharging, difference in quality, to what we would potentially be discharging if we were to move this into a desal type water facility? What is the difference there?
Sure. You mean different in cost or different?
Difference in, if you're already discharging water, and now we're looking at doing this for a desalination type, is it a difference in the discharge brine consistency, or what's the difference
that's
here?
correct. Well, I'm not sure if we can put the diagram, but just to understand.
We do have the slide, yeah.
But in the diagram, it showed that the desalination brine is concentrated 2 times, let's say, rough number, the salinity. So the salinity and the seawater 34,000, we will have 65,000 on the brine. So, but we're diluting with the 500 more or less MGD we have for the brine. So the salinity increase, we can manage to be in the range of 2 to 5% more compared to ambient. And this percentage, the impact on the environment, we can do tests. The species naturally can tolerate the salinity variation. So in that bay, there is a variation of salinity from 28,000 up to 38,000. So there is a large variation of salinity that is naturally occur, and the species over there can resist this variation of salinity. So the idea is that during the evaluation phase, we will do analysis of these variations and assess the salinity tolerance of the species to make sure that the 2% or 4% of the brine increase is sustainable. It will not harm the environment.
So if I'm understanding correctly, based on the water that you're currently using for cooling, that's discharging right now into. So is it the same concentration of salinity?
It will be not the same. That's what's the point.
It's not the same. That's what.
So they are discharging right now more or less the same salinity of the raw water, but high temperature.
Yeah.
And they have a maximum that is allowed in the permit. So in our case, with the desal project location, with the co-location, we will just affect the salinity in a percentage, let's say around 2%.
Okay. And so you said that you would need a feasibility study in order to look at what it would take to go into the Gulf.
Overall, so even looking at Oso Creek, we would definitely have to evaluate it more and make a determination. If the salinity was too high or we thought there would be an impact, it might not make sense to proceed that way, or we might have to size it differently or add additional water source to it, potentially effluent. There's potentially other solutions that you could dilute that water with to make sure it's not a problem with the salinity. The other option instead would be to take it out to the Gulf instead. You would have a higher cost because you'd be looking at maybe 7.5 miles of pipeline, taking it back out to the Gulf. But at the same time, then you would avoid any environmental impact.
What would be the difference of timelines as far as if you were to do feasibility for Oso versus Gulf? Is there anything there in that kind of timeline for just the study?
For the study, it'd be about the same amount.
About the
same. We would look at both options at that point and be able to give feasibility for cost and for the environmental.
Okay. Thank you for the information. Like I said, that's an area that for me specifically, and I know a lot in that region, would really be cautious to interfere with the system there. So thank you for the answer. My next question very quickly would actually be for the solar project, if you're still online. You referenced in your presentation that you had a variety of packages as options. If taking into account the size of the lake that you're in discussion, what is a ballpark that we're looking at for a fairly standard package? You know, the presentation listed a lot of information, but really no kind of estimates for us. What would be our commitment to this?
Sure. So we'd want to work with the city to understand how big you guys would be willing to go. So if we wanted to go into the ballpark of a 300 megawatt system, generally a good heuristic is 1 megawatt is 2.5 acres. So given like something like that, then we're looking at about $1.5 per watt.
Well, sorry, I'm going to chime in here. Hi, my name is Kathy. I work with Tate. What I would say is that in terms of pricing, so I think that's what your question is about. What we're suggesting is that the city hire Noria to do a feasibility study, and the feasibility study pricing is very variable. We would have to work with you in terms of the scope.
Ma'am, I'm sorry. That time period is up. Councilmember Paxton, if you have further questions, you can submit those to the presenters. Thank you so much in writing. Next, we have Councilmember Hernandez.
Okay, I have questions. Quick question for Eevee Ranch, Evangeline, Barney Davis, and then Noria. Okay, first question, and it's a matter of semantics in terms of what we mean by treated water versus raw water. So I'm assuming you're talking about raw water, or is it potable water?
We're talking about potable water.
So it'd be potable water. So the $6.50 or $6.64 is for potable water, treated water.
That's correct.
Okay, thank you very much on that. Evangeline, Ed.
I'm starting to feel like Sally Fields. You like me. You really like me.
Well, Ed, the reason I called you up is I wanted to apologize to you. I know that the negotiations did not go well last time, and I hope we can work together on this one, because a combination of groundwater from your option as well as Eevee Ranch, is over 50 million gallons a day. And I'm a worst case scenario kind of guy, and I can see it very well that our reservoirs aren't recharging at the rate they should. And we could have a situation where we don't have those reservoirs. So it's incredibly important for us to try and make a deal this time. The challenges that we came across last time is that we didn't have the capacity in the Mary Rhodes pipeline, or that's what we were told, that we could only take in 12.5 million or around that point after addressing. Is that still accurate?
I'm not the person to ask that, Councilman.
Okay, we can ask that.
That would be your staff.
Okay, so in order to get the full 25.4 million gallons a day, would we have to build a conveyance or a pipeline directly to Owen Stevens?
Yeah, the answer is yes, Councilman.
Okay,
yes.
So the challenge is, what size would that be, right? If it's for 25 million gallons a day, is that the maximum we can do per your permit?
In our negotiations last summer, we were talking about taking the water in 2 phases. And
no, I understand, but in terms of total, for the total permit.
The total that we can provide you is 25.4.
Okay, so that's the maximum. You don't need something like the size of the Mary Rhodes pipeline in order to convey that to us. Okay.
You don't need a pipeline that.
So that's number one. So what size pipe would that be for 25 million gallons a day? 42 inch?
Yeah.
42 inch. And you could be, Eevee Ranch mentioned high density polyethylene pipe. Would that?
Sounds great to me.
Okay.
Sure.
All right, so devil's in the details, right? Devil's in the details. Everything adds cost, especially if you try and oversize something that will, for other reasons. Okay, so we're good there. Hopefully, and like I said, I apologize. I know it was a tough negotiation, and I want to make sure that I convey that to you.
Yeah, thank you.
Thank you. All right, next one, I believe Barney Davis. Okay, a little later from now, we're going to be talking about wastewater reuse. We have 2 wastewater treatment plants that provide fresh water discharge into Oso Creek as well as Oso Bay. There might be a possibility that we reuse that, and that fresh water source would not be in Oso Creek or Oso Bay. So how does that change your dynamics?
Sure. Yeah, great question. Well, in the evaluation, if it does as a scenario, probably we will, in parallel, we're analyzing the scenario to discharge in the Gulf. So if there is not sufficient volume and the study can prove that it's not a good solution to dispose in the Oso Creek, then the option of go to the Gulf of Mexico is.
So I'll refer to as the Gulf of America.
Yeah,
okay.
Gulf of America.
just for consistency's sake.
We were just calling it golf.
Yeah.
Let's call it the Gulf. How's that? I had to throw that in there. Sorry, I saw that in Sarah's presentation too. I was going to correct you as well.
Anyway.
So some levity here. Some levity. All right. So we were talking about. You said a 7.5 mile pipeline, right? And I think Sarah, you said 1.8 miles plus an additional half a mile for discharge. So a total of 1.8, right? As opposed to a 7-mile pipeline, right?
Yeah, we can't hear, so none of those responses are we can't hear those unless you speak on the mic. There's some mics
Sorry,
there also.
we're kind of comparing here.
That's the distance off of San Jose Island. The total
Okay.
distance from Harbor Island is 3.1 and
So
3.6.
3.1 and 3.6 versus 7 miles?
Yes, sir.
Okay, thank you.
And honestly, the 7.5 could probably be, it might be able to be a little less. We'd have to look at that. But I think the point was there's kind of a sweet spot where you'd be able to put it where it would have no impact environmentally. So we were looking at 7.5.
Okay, I guess, this is probably the furthest thing out from what's available to us. So I just, there's some challenges there that I think you need to take a look at. Okay, thank you very much. I appreciate it. Noria, is they still online?
Yes.
I'm doing good. Question here is that obviously you have to have an off-taker for the power, and then also would we also be able to utilize that power for dam operations or for operations at the on-site?
Yes, absolutely. So we have a number of large industrial customers that we could structure things called virtual PPAs with. I guess one name names. The other option is to go straight into the ERCOT wholesale pricing distribution.
Okay, and that'll be done by your evaluation. Obviously, you're not familiar with all our area, and that's how, so I understand that. Honestly, I have to apologize to you as well, because honestly, I thought this was pie in the sky. I didn't know there was an actual company that did this with examples. So, you learn something new every day.
Absolutely, happy to show you if you want to come out to Galesburg, California, and see our system out here.
Okay. In looking at some of this stuff, I mean, you answered kind of the questions where I was talking about, and you said, and Councilman Campos said it was about a 2-year process from the time you start, 12 months for permitting, and then another 12 months to install. Is that correct?
12 months for permitting. Install can actually be very fast. There's no grading needed or anything like that. So more closer to 4 months, 4 to 6 months.
Does that include acquisition of all panels, and are you not going to be affected by any kind of tariffs or anything?
We are. We've been affected by tariffs for all of solar's history, so we're well equipped to handle those. But that does include procurement. We usually do procurement in parallel with permitting and things like that. So yes.
Okay. Thank you very much. I appreciate the information.
Absolutely.
Okay, Nueces River Authority, since I've got 2 minutes here, I wasn't sure I was going to have enough time.
Yes, sir.
Okay, I know we're talking about the $12 per 1,000 gallons, and we're talking something out in the future. What was that estimate based on? Was that on the HDR assessment for the Texas Standard or Texas Water Development Board standard?
Yes, that was based on the Region N Texas Water Development Board standard.
Okay, so as I understand, that's based on bonds that are sold over a 20-year period. Is that correct?
That is correct.
And our information is based on a 30-year period. Is that correct?
Yeah, that's correct, Councilman.
Okay, so that cost is actually based on the standard, not necessarily what it would be if you had a public-private partnership or a 30-year type financing.
That is correct. You have to base that on the TWDB standards to include it in the plan, and that's what it was based on.
Okay, and I wanted, I know we've talked about this on several occasions on what the state plan is in terms of what Senator Perry envisions with the funding for water. Most of it, or a good portion of it, or half of it, is for some sort of conveyance system to get water from water sources to the rest of Texas. And from your discussion earlier in the questions, that was mainly kind of what you envisioned, that the conveyance would be paid for by the state, and you would be providing the water through the facility. Exactly.
The oversizing of the conveyance would be paid for by the state, and they would certainly help us with the financing on the initial sizing of it. But, one of the things that I didn't explain very well is we don't look to be anybody's only source of water. So we don't need to have 100% backup on any of this. So that's why we really want to build the 144-inch to start with and not have to come back in and build two.
Okay, so in terms of what participation you would need from the city, it would be simply a reservation fee? The
reservation fee would...
You wouldn't have to have any of our staff involved, no cost from us other than that reservation fee, which you said at 7.5 or 0.0075 cents per thousand gallons?
I like to talk in acre feet. It's 24.48 per acre feet.
Okay, thank you very much.
Thank you.
Thank you very much. Next would be Councilmember Vaughn.
Well, come on up, Sally Field. Well, I really like the idea that your water is good water, potable, and it's not brackish, so I'm glad you made that clear. Is the water subject to drought, groundwater? And
No.
and I have a second question. And
It is not.
It is not. It's not subject.
It's not subject to drought.
And how do you minimize subsidence?
So our well field that Steve Young has designed has been to accommodate, it's a Venn diagram. One is to maximize production. Number two is to minimize TDS and chlorides. Number three is to minimize subsidence. And number four is to mitigate impact on adjoining wells. In particular, we want to avoid the wells that Sinton has next to it. And there's a little town, Peter, what's the little town? Just
St. Paul, you're talking?
St. Paul. St. Paul has a municipal well. There's also neighbors around us. So we've pulled the wells into the middle of the ranch as far away as from the other people as we possibly can. That well field has 23 wells distributed along the north side of the ranch. Subsidence has been an issue in the Houston area where they pump from the same aquifer. It's the Gulf Coast aquifer. There, the soils have a lot of clay in them, and so as you pull water out of clay, it shrinks. Steve Young, our engineer, thinks we'll have a little subsidence, but it will be on the ranch, not off the ranch. So our neighbors shouldn't be affected whatsoever.
Well, thanks for saying the correct subsidence. Thank you.
Subsidence, yeah.
The other thing is, because I'm always concerned when we did Nueces River, when they drilled the wells, is it going to affect any of the rural people? Because that's what a lot of them have their water wells. Is that going to affect?
Yeah, and that's what we call mitigation, and that's why we're locating our wells as far away
Okay,
from
well,
them.
I figured that, but
Yeah.
I wanted you to say it.
Yeah.
And the other thing, and I think I already know the answer, but I just think it's important, is the City of Sinton's water supply approved for consumption by the regulators, the
Yes.
agencies? I
Yes.
figured they were.
Yes,
Just
that's
wanted
an
you to
approved
say it.
water system.
Yeah. and
The old-fashioned approved water
You've
system.
been doing it for 40 years.
Yeah,
Okay, I think that's good with me. Thank you.
thank you.
I have a question for Nueces River Authority.
Yes, ma'am.
The other day I heard that it was going to cost $3.8 billion. I heard that figure somewhere.
3.5 is what
well, just
that's
give or
close, very close, yes.
So I think my question is, that's the assumed cost, and I know you can't say for sure what it is, but is that in today's dollars or future dollars?
That's in today's dollars.
Today's dollars. So it could very well go up, because you're saying, what I understood was it won't be until 2030?
Well, we hope to have it in service by then, but that's based on an estimate that has a lot of contingency.
Mm-hmm.
So some of the contingency is built in for that inflation.
But it could very well go up.
It could, and it could go down.
Okay. Have you, that's true, maybe under, well, never mind, I'm not going to say what I was going to say. Have you do you have an agreement with the port to lease the land yet, or is that?
Not yet, but we're working on it.
It's in negotiations. And who will design and own the distribution lines to deliver the water?
The Nueces River Authority will.
And you'll own them?
We will own those.
You will own
yes,
them.
ma'am.
Okay.
Well, the state of Texas is going to own the oversized part of it, but
Yeah.
we'll pay that off over time.
Yeah, they own everything. Okay, that's all for you. Thank you.
Thank you.
And the Port of Corpus Christi? For the first time in years, I have hope that all of our entities are going to start working together. So I don't know if you're going to answer this question, but I'm going to ask it. Will the port give the city first right of refusal?
I'm going to defer that question.
I knew it. I knew it. Well, hey, look, he's here, so that's good.
Obviously, we have to work through the contractual arrangements, but I think we've been asked by all of the entities in the area to consider a couple of things. One would be to protect the city's CCN region. So if Nueces River Authority, for example, wants to sell water within the CCN, they'd have to sell it to the city. And then the other is some sort of right of first refusal on that. That would obviously require an interest from the city in wanting to buy water.
Sure.
So we're going to continue those discussions. We met with Peter and Mayor Guajardo yesterday to talk about just those things. We're open to having those conversations with you, with the city.
I thought it was important for the public to hear that.
Sure.
Thank you. And the last one I've got is from Noraya, the solar. How does the solar impact the recreational use of the lake, boats and things like that? I know when you're in a drought, you may not care about that, but somebody's going to care about it.
We do very much care about that, but I'll kick it over to Alex to answer that question.
Yeah. So the portion of the lake that would be covered with the solar panels would be off limits to recreation. There's typically a buffer around it, similar to like a hydroelectric dam. But in terms of other recreational opportunities, assuming you don't cover 80 to 90% of Lake Corpus Christi with the panels, there's still ample opportunity for recreation. There's no noticeable impacts to fishing or that kind of item. So yeah, it definitely can be in tandem with current recreational opportunities.
Okay, thank you, Mayor.
Mayor, thank you. I'm almost apprehensive about my time here because I look at water in the today, tomorrow, and the next day. And today is all about the wells and increasing capacity in the pipeline and seeing if we can't claw back some water from Formosa. You know, that's really all I care about. And tomorrow is getting Inner Harbor going, under construction. And the next day are these wonderful projects. And I promise you, I don't mean to diminish your projects, but I mean to try to articulate that if it were up to me, if I were God for a day, I'd say spend all your money on time on today's and tomorrow's activities, because every time I turn around, it's like, what are you doing today to get water so that we can, get out of this situation? So I'm going to couch my conversation and my questions based on that, because I don't want you guys don't think I don't care. I just tell people, most of us want our public officials to put two eyes on the road in front of them, and then that third eye maybe on the horizon, but two eyes in the road right in front of us. The other thing I mentioned it when we talk about, I guess, with Evangeline, is that my sense is that we're going to get to, Category 4, which is 75-ish MGD, and then if we can claw back some water from Formosa, that gets us to 85, 90, and so I would submit we're reaching our capacity, so I just kind of keep that in mind. Eevee, can I ask you guys a quick question? So do you have to get, you probably answered it, but you have to get TCEQ permits to drill it and send us the water? I missed that if you do. Do you need TCEQ permits?
Well, we certainly need Groundwater Conservation District permits to
Sure.
drill the wells.
Right.
And as a public water supply system, the water exiting the facility will likely require TCEQ permits.
What animal is discovered in the alleyway? So I guess my point is, if it's you in the Groundwater Conservation District, that's awesome. If it's the TCEQ, then that's a different timeline. I just didn't know if
Well, not necessarily. They're running in parallel. if necessary. They would run.
Well, I wish you luck on TCEQ permitting process, better than we've had. You know, that's my point is, but I hear what you're saying. If they run the same timeline.
We do have disposal wells for the brine.
Right, and that would be permitted,
And
right?
that would be permitted correctly. And so that is a part of the process.
Got it. Love the project. Want to talk some more. Thank you very much. The next one's the Harbor Island. I guess that's so TC. You got to get a TCEQ permit. I get that you have to get the Corps permit, and you got that wonderful letter that says they're going to expedite it. Man, that is awesome. God bless you. Do you have to get a TCEQ permit again?
We do need a TCEQ
Right, for
permit
the-
still for the water rights and one for the discharge for both in the Gulf of Mexico.
Is there anything about discharging off the coast that allows you to expedite the permitting process with TCEQ?
You have to go a significant distance further in order to get expedited permitting, but it's not cost effective to go that far.
Got it. That's all that matters. I appreciate your time. Thank you. NRA. John, thank you. You know, I've said publicly, appreciate what you guys are doing. Would love to see it at your table if you ever have an extra seat. My point is I appreciate what you're doing. I didn't understand how a P3 would get you longer lasting membranes. I mean, I guess if I was building it, I can go buy the same membranes. No?
I glazed over that because it's 10 minutes. But
No, no, and I'm down to
let me do
6.
that. Efficiency, operating experience grants efficiency. After you do it a while, you learn more about it.
Okay, thank you. And then you mentioned the 3 plants. I didn't realize that there's some document that says the state's looking at 3 locations, one 450 here, and then maybe smaller one down in the valley. Can we get a copy of that?
I don't have a copy of it yet. I understand it's out, but it basically shows.
No, I get it. I just hadn't seen it
conveyance
before.
going up, and it's tied to that conveyance, and they show those sources, and then they show a source coming from a neighboring state with some groundwater.
And Ryan, I think you're maybe listening, sir. I'd love to get. I think we'd all like to see that document. That's
I'll see if
really
I can get
interesting.
my hands on it.
Thank you, John. Thank you, sir. That's all I had. Thank you there. Oh, John, I'm so sorry. One more time. The reservation fee. So that if we pay a reservation fee and the project, for whatever reason, doesn't work out, do we get that money back?
Not at this point in time, no.
Got it. Okay. Thank you, sir. Thanks. Evangeline, yep, please, sir. Sally. Let's just, for the sake of argument, say that we do want to desalinate or do something with that water as it comes off. I get it. Do you have a permit for that?
Don't need a permit for it.
Okay, so if we want, then we would have to get a permit. If we want better water quality than that's coming out of those wells, would we have to get a permit? I thought you had applied for some permit that said you were going to use the creek to discharge?
No, sir.
Okay. So you have no permit, but I get it. You say you don't need one. I'm just saying if we decided we needed one, that we wanted a better quality before we did whatever to it, we would have to go get the permit. Okay. That means, I understand what you're saying. Don't need a permit. I hear other people saying, no, you don't need a permit for that quality of water, but if you want to match our quality water, which may be wrong, we would have to get a permit to do that. All right, that's all I have. Thank you, sir. Barney Davis, if you do it inside the fence line, do you get a cost? How do you get lesser power by being inside the fence line?
Yeah, sure. The first point is that the advantage is we're taking warmer water. So the raw water, let's say, will be at 25 degrees Celsius. So the cooling pond will cool in the water from the process. The process came, I think, 50 something degree, and the outlet is 35. So the warmer temperature increase the permeability of the membrane. So you need less energy. So this is an advantage. So the OPEX is low.
But if you're inside the fence line, do you get actual power cheaper?
This is a statement I made. I need to study better the composition, but usually you have a certain charge for transmission. So in case you are far away from the generation, you have transmission lines, transmission costs. So in case you might not have it within the generation.
And you mentioned the transmission. Let's see. We have an existing line, I guess, on the south side that you could potentially tap into. Yes. I might offer that, and Gil's talked about that outer loop with the bridge going to the island. You could also co-locate, an outer loop around that. Yeah. That would be interesting. A quick question for my solar guys, thank you, folks. Just rush through these. So do we own the land? Does the city, I don't think the city owns the land under the water. And if so, does that require getting the landowner's permission to put solar panels above their land?
It would. So we would have to understand who owns the land. I think it was our understanding that Corpus Christi does own that surface water, and we would have the lease with that entity.
The question is, I know we own the surface water, but we don't own the land underneath the surface water. Just a question we might want to ask ourselves as we move forward.
I don't think that would matter. Just as a follow-up to that, this is Kathy, Tate's colleague. Since we're just putting our material on the surface water, and we can anchor to the shore as well, if we want to avoid anchoring to the ground, we should be able to avoid any issues if Corpus Christi doesn't own the underlying surface.
Got it. I guess that would be something we'd look at going forward. My last comment or question, this is good, is John, or somebody mentioned, maybe as you can't, including in the conversation, a recognition that the city has a CCN that it wants to take care of, and we don't want any entity to come in and cherry pick their customers. I would submit to you that our service area is larger than our CCN.
Absolutely, and we've got a plan for that, which they might have reached out to the mayor yesterday, our board president, try to set up a meeting so we could discuss that with Peter. Did they do that? Hopefully.
They're working on it. Yeah.
Okay, good. So we've got a plan for that, to set a meter, and that way we didn't have to build a conveyance system to that point, but that way people that draw from your lake can get water. But listen, we are not in competition here. There's need for both of these plants, and we've been supportive of your efforts.
Got it. Thank you very much. I just want to reiterate that our service area is larger than our CCN, so we have an interest in protecting our service area, which is larger than our CCN. Mayor, thank you so much.
Okay, Councilmember Barrera.
Thank you, Mayor. I think you put me at the end so that way everybody could ask all the questions, since I tend to be loquacious. First off, Bob, can you come up? I may have some questions for you, and I'm going to do this a little bit different. Paulson. Yes. The only reason is because I want to go back to some other things later. And Drew, I want to do this a little bit differently. I'm going to ask some of the questions to you, and just be ready, maybe in that first chair. And then, and then go from there. And then first off, Catahoula, once again, it's 30 months that we're looking at, 30 months that we would look at probably in lead time, and that's 28.5 MGD?
That's correct.
Okay, and now let's go back to the TDS. Okay, so I don't know, not knowing any better, so we'd still have to treat the water to get it to the...
Yeah, let's be clear. We believe the source is brackish. It ranges between 1,000 and 5,000 TDS. That necessitates, to create potable water, we have to build a reverse osmosis plant. So the water treatment plant would be located on the Eevee Ranch.
Got you.
So the only water leaving the Eevee Ranch, being put in that pipeline, going to Kingsville and on, would be potable water.
Okay, and then you've got a request to the port to be able to help you determine all this. And you made a request. Okay.
That is correct.
Okay, so, all right, thank you very much. I appreciate that. Okay, and then Ed, first off, thank you. We met when I first got on the council, and so it's been a little over 6 years. So number one, thank you for sticking around. I want to thank the staff also, because this is a two-party deal. It all comes down to the cost and what the ratepayer is willing to pay. And I think that was really the challenge. I think it was all done in good faith. I just want to clear that up. It was all done in good faith, and it all depends. If you've got a commodity, is there an appetite for the commodity and willing to pay for it? And I think we weren't at that time. But there is one thing, I guess one of the things, and Drew, maybe just stand up and be ready. So we had said that we could probably move along with 7 MGD very quickly, that we could take out of put into blend into the Mary Rhodes pipeline, because the salinity was still higher a little bit higher than what our standard was to be able to put into our system, correct?
Right. So that number was 12 MGD. So we had an outside consultant that looked at and did a blending study to understand what the maximum amount we could put in without having to treat it. So I think there's a little bit of a different of opinion here. With due respect to my friend Ed, we believe that at a certain threshold you would have to treat that water.
Okay, so we could get 12 MGG, pulling them into the same thing, put it into, because that's the thing we need to look at here, so that way we're going to reach a very difficult threshold in about 6 months, and we're going to have to make some very difficult decisions. So in my opinion, other than what we're doing already, then that's probably the next course of action that we would take, and then determine that cost, and then we blend the rates. So what is it? Okay, so one other thing, Ed, is that you think you could get Steve Young to sign a football for me? Anyway, thanks. Appreciate it. Didn't have you up here for much. Okay, so Barney Davis, and this is just a confirmation. What is it? So up to 100 MGD, right? But realistically, timeline is, because we're way in the infancy. I mean, I'm thinking off the top of my head, 48 months.
Talking about construction, right? Just construction?
No, if we had a facility that to be able to pumping water.
Yeah, this will depend very much on the solution for if we are going to go to the Gulf or not. This will determine a lot the schedule.
Yeah.
But yeah, for 48 months is not feasible. The only concern is this longer.
Yeah, and I think that's the appetite that the community of all those that are supporting it is they want it to go out to the Gulf. So that's my understanding. And yet we haven't been able to determine the cost. I mean, however, it's very feasible. I would say that other than Evangeline, that would probably be the next direction that we would go. Okay, thank you very much. Floating solar panels. Oh yeah, are they? Noria?
Yep.
Okay, so I guess what would it take to engage with, I guess what would be required to engage with your organization?
Kathy, would you like to take?
Yeah, sure. Yeah. Hi, all. Kathy, SVP Business Development for Noria. Didn't introduce myself earlier. In order for us to proceed, we would start negotiating with the city a scope of work for a feasibility study. That would be the first phase. The feasibility study takes about 6 months, and so we would work with you to determine what scope is appropriate, and then the pricing would go accordingly. So it'd be dependent on what items you guys find valuable, whether that's economic, technical feasibility, et cetera. That would be the only cost to the city that we anticipate, because we would be determining offtake and other means by which we could build the system without taking any capital from the city, instead just paying the city a lease rate. So that would be our goal. And in order to engage with us, we have our email at the end of the presentation. We'd be happy to have further discussions with the city on a scope of work and feasibility.
And have you been engaged with another public agency where you've had to go through a procurement process to be able to, you know, that's the whole thing. We'd have to figure out a procurement process so that way we can determine that it's competitive. And you know, because obviously I'm sure it'd be upward of $50,000 to engage with you. So have you been engaged with any other municipalities or public agencies where you've gone through a formal procurement process?
Yeah, so actually it's state by state dependent on whether they can sole source, right, for a feasibility study. And so we could help look into that if that was something we could do. But what I will say is that, you know, in terms of the large chunk of who is actually engaged for construction and of the system, that would be run through a traditional RFP. We can dig in a little bit more in terms of whether the city is capable of sole sourcing with us for feasibility. And if not, we can look at alternate mechanisms by which we just spend the $50K and see what we can do within that scope. It would be very much more pared down scope, but we could start with that.
And I'm curious, I'm running out of time here. So how do you determine the perimeter, the size, or what you're going to utilize? I guess I'm just curious, because obviously Lake Corpus Christi is vast and somewhat linear.
Yeah, that's a great question. I'll let Tate take that.
Yeah, so we work with you as well as recreation departments within the city to understand, you know, where is that balancing point where the community is engaged and excited about the system, but understanding that they can still have, plenty of recreation on the pond. So obviously we can scale up, and as I said, very modular these systems are, so it can scale up as big as we want. So it'd really just be a conversation with the city.
Okay, and Bob, I'm informed that you're not on the list, so I can't ask questions. But thank you for coming up. Thank you for showing up. And then, John, first off, don't worry about getting up. Thank you for, for emphasizing that this is, that you support the city's project. And I had the same question as far as the CCN deal and count, there's 7 counties. Here's one thing, and Drew, come back up a little bit. I'm looking at this, and we want to diversify our water. I mean, obviously, it's a demand issue. It's a demand issue, and right now our demand in the summer is going to be what?
About 130 million gallons a day.
130 million gallons a day. So right now and I guess we'll go over this later on because I don't want to, when we get to your deal, but I almost think that in some sense or another that we would partner with the NRA, because if we're looking at, and bear with me, John, Catahoula is 28.5 million gallons. Evangeline is 25 MGD. Barney Davis, 100 MGD, which I think is a long way away. The floating solar panel still has to be vetted, but that in itself right there is about 153.5 MGD. And I think surface water, if we're putting this network together, would probably be a little bit more advantageous than, just my opinion. And I don't know, you're the expert, much smarter than I am. So I was just thinking along that line. So, okay, yeah, like I said, I like the idea today, tomorrow, and what our long-term plan is. And then once we get to your presentation, I'll ask you some more questions. Thank you very much. Much appreciated.
Thank you, Councilman. Okay, that takes care of everybody. I've got a few questions, obviously, and as you've all heard, many have been answered. So I really appreciate everybody coming forth with some great questions. Mr. Cross, just again, some quick questions, just to clarify, really. So in terms of drilling, and I'm going to call them drilling challenges, because you said this, let's see, 1.5 MGD per well could be delivered. You got 12 wells. And what was the timeline on that? 6 months?
I started with 6 months for 3 or 4 wells. I would have to ask Drew, y'all engaged Weisinger, I think, to drill your wells on the Nueces River. It's tough to get attention of drillers. So again, I wanted to introduce this concept. You're starting to drill down.
Absolutely. But as you're, you all are here because of a timeline and our sense of urgency. So well, if I'm correct, I believe remind me how many months? You can just say it from there.
45 days.
45 days per well. I don't know if that's how yours work, but my point is this. So, and I think somebody brought this up. You're able to get 6, 12 wells being drilled at the same time? 3 to 4? We won't hold you to it, but.
Sure. Seriously, I don't know.
Right.
It depends on being able to get driller or drillers out there at the same time.
Right.
When it's an emergency and you're willing to pay up for a driller to show up with 2 crews, 3 crews, yes. Again, I wanted to introduce the concept today. Y'all run down the road with the Nueces River concept. We're permitted. We've got good water. We're right by the pipeline. It's all there to strike some deal.
Absolutely. Thank you, Mr. Cross.
Thank you.
I appreciate you being here. Okay, let's see here. So, and you don't have to come up, but Dr. Mintz, you said y'all are working on moving through the feasibility study. I mean, that's right. That's in motion, I guess, to see where it goes through the port. Okay, thank you. Mr. Byram.
Yes, ma'am.
Mr. Byram, so you mentioned, okay, $3.5 billion, the cost of construction today. How could that go down by 2030?
Well, this contingency that are included in that, what I call a Class 6 estimate, there's a lot of contingency there, and there's a lot of safety factor in there. And I just don't anticipate it costing that $3.5 billion, to be honest with you, but I can't guarantee that. So I'm going with the 3.5.
The 3.5, again, is just for clarification, that is today, if you were to build it.
That's right, and that includes about 21 miles of pipeline.
21 miles, okay. Okay, and let's talk quickly about the state participation. So it sounds like you're saying, well, you said the state is going to pay for the pipe.
If the state participation, if this legislature votes
Sure.
for that bill, yes.
Right.
They will have an oversizing agreement with not only NRA, but other water purveyors that are going to participate in the big state.
So you wouldn't be going through the TWDB as an applicant?
I'm sure that they will send that back through them, but that remains to be seen how they're going to fund that.
That is exactly what we've been told.
Yeah.
Is that that 2.5 billion, 3 billion, I mean, Perry would love 5 billion, but let's just say 3.5 because that's where we're at now.
Yes, ma'am.
They're at now.
Yes, ma'am. Yeah.
Should that go through, it's been said that it would be, those monies would be going through the Texas
My understanding,
Water
that's where
Development
they want
Board.
to put it.
Correct.
Yes, ma'am.
So what if you didn't get approved for, I mean, that's for the whole state of Texas. So we can go back essentially and say, we'd like to apply for more money for one of these projects, let's just say.
Okay.
So if you're counting on those dollars, 2.5 billion is a lot of money. But when you're talking 21 miles in pipeline or anything else we've heard here, you know, and across the entire state, there's no guarantee, unless you're telling me there is, that this
there's no
entity
guarantee we'd get
would
that
get all the
money,
money to pay for this.
We would apply for that money.
Okay.
They're wanting to put $1 billion in
Each
a
year.
year. You know,
Right.
that's kind of wishy-washy. We're not sure that that's going to happen
Right.
either, Mayor. So we would have to go back, and as I told Gentleman Scott earlier, we would have to go back to the drawing board, and I'm sorry, I told Mr. Roy that, and revamp, you know, and we might have to go in with a smaller line and have duplicity later on. We don't want to do that because we don't look at being anybody's sole source of water, you know.
Sure.
So it'd be better to go in with the full-size line. But these things are up in the air until we see what happens in June.
Okay. Okay. And then what is the scope and the timeline for, I think it's Black and Veatch, correct?
That's right.
Your consultant? That was approved recently at an NRA meeting.
Task 1 is a 6-month project, yes. That is task 1, and then we'll enter into task 2 after the findings of task 1.
But the scope of that, roughly?
The scope of that in timeline is 6 months, the first task. And there's 7 sub-tasks associated with that.
Okay. Okay. I think that, power infrastructure at Harbor Island. What is I think the answer is no, but there's no available power infrastructure today, correct?
There's one near, but it's not of sufficient size. So that request has been, we're starting on that request now, even though we're not anywhere near, but we're starting that because we want to know their timeline and we want to know their estimate.
Okay, so we don't know the timeline right now.
No, ma'am,
as
we
to
do
where,
not.
But you're looking into that. Okay. Thank you, Mr. Byron. Okay. All righty. So it looks like we've gone through all the presentations, all the questions on those presentations. It is 12:13. We'll go with 12:15. We are going to break for 20 minutes. We'll be back at 12:20, and we'll start our city presentations. I'm sorry, 12, not a 5-minute, I'm sorry, 12:35, 12:35. We're going to take a 20-minute break. We're trying to be as efficient as possible and get through all of our presentations. So thank you for being with us. We'll be back in 20 minutes. If everyone can please. Okay, we are back from our shortest lunch break in history. And we are going to go to our planned and approved water supply projects. We want to keep everything on time. We have four. We have four. Four different projects. We're going to spend 5 minutes on each and then follow the same process. At this point, each council member will also have 5 minutes to ask questions and answers, or ask questions for answers. So the first one is the Inner Harbor Treatment Campus, and that is, Mr. Drew Molly.
Yes, ma'am.
5 minutes, sir.
Good afternoon, Mayor, Council, Drew Molly, Chief Operating Officer. So I'm just going to take you through, I'm actually going to do this a little bit in reverse. I'm going to start with this slide here because really I think what's important to note today for the Inner Harbor Water Treatment Campus project is that this project has taken quite a bit of time to get to where we are today. If you look at the timetable here, you can see where we started. And this project has been in the region end plan for many, many years. 2014, I believe, is when we got in. And we know that large projects like this one, large projects take time to deliver. And that's a good thing. It's a good thing not that good that it takes long to deliver, but they're vetted. And they have to go through those processes, especially when you're trying to attain low interest financing through Texas Water Development Board, which is what we have for this project. We've been very successful in leveraging all the types of financial resources that we can get for this project. We have low interest financing through the Texas Water Development Board. We have a dedicated fund that one customer class pays into for this project that'll generate about $180 million over the life of it. And we believe that we still have some work to do in terms of getting more funding, grant funding, frankly, from the federal government. The Bureau of Reclamation is one such entity. We have done a lot of work when it comes to the environmental due diligence. We've done our own modeling. We've done core mix modeling. We got results. We submitted that to the TCEQ. The TCEQ did their own independent modeling. In order for us to get a draft permit, they had to get the same results or close to it, and they did. So that was when we got a draft discharge permit, for the for the project. And then we went through a series of reviews by the EPA, where the EPA got involved, and they asked a lot of good questions, and we met with them, and we showed them the science and the data. And so now we're at a point now where in the next week, we will be going to the TCEQ Commission for a final permit. We're also working with the Corps of Engineers. In order to do this project, we have to do some work in the waters of the United States. So we continue to work along those lines as well. I think the other thing that's really important to have is you got to have a good partner. We've selected Kiewit, who is a world-renowned design builder. They have built desal. They have built the largest desal in the United States at Carlsbad, California. It's a 50 million gallon per day plant. So we feel like we have taken the necessary steps to get here. Some of us may say it's taken a long time, and I think many of us feel like it has, but we feel like we're in a good place to continue to deliver a project that is got a lot of merits behind it. Most importantly, drought-proof. What I will say is the last bullet here is our estimated delivery on this project is 2028. So second quarter is when we're projecting that. I will just kind of give a very quick high-level overview. One of the things that we think is really important is minimizing the cost, which is why we think this project makes a lot of sense. We heard from previous presentations today that pipeline conveyance is expensive. And so part of this project has been to minimize that pipeline conveyance. This project will be built in the city where the infrastructure is already there. We're going to be using the navigation pump station to help us distribute that water into the city. The other thing that I think is really important is we can all recognize water security, water resiliency is imperative. We are a regional water provider, and we have one water treatment plant that was built in 1954. And while it's a very good plant, every city larger than us, the 7 larger cities, have 3, and we have 1. And so this provides us with that additional security from a drinking water standpoint. We also would like to note that a big part of this is making sure that we have the community's input. We believe that part of this plant is going to have a water education center. We think it's important to have children and kids and adults, for that matter, coming through and understanding how these types of plants work, the benefit it is, and how we were able to do this in a way that had good environmental stewardship, which is a big part of the importance of this project. There's only 2 other water treatment plants that have education centers. There's Houston, Laredo, and actually 3, El Paso. We know that the state of Texas is looking at this project. They're looking at us. They're looking for us to lead the way in projects that provide drought-proof water supplies for communities. And so we believe that this is a good project, and that concludes my remarks. Thank you.
Thank you, Mr. Mully. The next presentation is La Quinta Water Treatment Project.
Good afternoon, Mayor and Council. My name is Esteban Ramos. I'm the Water Resource Manager for the City of Corpus Christi. Thank you for having me today. I want to provide you with a little update to our La Quinta Water Treatment Plant project and discuss our goals and remind the community in the area of what those goals and the activities behind the decision of La Quinta site, seawater desalination treatment plant was. This site is a long-term water solution for the coastal bend. La Quinta would be sized to produce 40 MGD, million gallons a day. The water treatment project is sited in the county of San Patricio, across from the San Patricio Municipal Water District. And this was a key decision in the siting of this project because it allows us to leverage the ability to provide for distribution, which would then lower the cost for water. Because as of all we know, that it goes into the treatment and then the distribution is the main costs in any water supply project. The City of Corpus Christi is working with the TCEQ currently to obtain all necessary permits. The city has been granted its intake permit or its water right from the Texas Commission on Environmental Quality. So we're really excited about that and the partnership with the TCEQ. The city is also currently working with them to complete and finalize the discharge permit. The discharge permit in this is going through its technical review for core mix modeling and other factors that will make sure that this project is an environmentally responsible project for the area. The next step in the process would lead us to the procurement of the La Quinta water treatment project, and this would be identified at a time when we have the right customers and the need for the water. The roadmap for La Quinta has begun, as Drew mentioned earlier, with the Inner Harbor back in the 2015 timeframe. This project went through many environmental and economic valuations. We looked around over 21 different sites, and we came up with 2 sites, the La Quinta and the Inner Harbor sites. And that all revolved around the ideas of where to treat the water and where to distribute the water and where the power would come from. In 2017, the city selected these sites and submitted an application to the Texas Water Development Board for funding from SWIFT. And this, again, went back to how we were going to finance this opportunity for a new water supply in the best feasible way. And taking advantage of those funds that are available through the state process is one of the best opportunities for us. The city has been granted, again, its intake permit, and I know I'm repeating myself on that, but it was very important, and it shows the commitment that the city has to its long-term water supply planning, and that we continue to work with the Texas Commission on its discharge permit activities. The final steps in the facility roadmap would be to complete the land acquisition, which we were already in discussion with Oxy Chem, who is the owner of the property right next to San Pat Municipal Water District, who we partner with. and then work towards completing in the procurement process and beginning with the core permitting through the federal government. So these are kind of the road steps that we have, and then we completed with regards to the La Quinta treatment plant. Thank you.
Thank you, Esteban. Our next presentation is on wastewater reuse. This is a 10-minute presentation. Yes, sir.
Okay. Thank you, Mayor. Thank you, Council. My name is Dan Olson with Garver. We're a consulting engineering firm working with the city. I've got Taylor Hecht also with Garver here with me today, and I'll be just walking through some thoughts related to wastewater reuse and how that could be applied here in the city of Corpus Christi. So I'm going to quickly run through the different types of potable reuse. Where has this been done before in Texas? The scope of our current project that we've been working on with staff, and then a quick project timeline. Types of potable reuse. So there's various types of water reuse in general to consider. The first is non-potable. Many places have been doing that for a long time. That's regulated in the state of Texas under Texas Administrative Code Chapter 210, and that can be done through both non-contact and contact reuse. So when we're talking about non-contact, that's type 2 reuse, requires less treatment. Human contact is type 1 reuse, requires more disinfection, more barriers to prevent illness. Non-potable reuse is still a very basic level of reuse, requiring no advanced treatment processes. So the city's used water goes to a wastewater treatment plant. Typically, we're talking about maybe one additional process that may already be present there, like tertiary filtration, and then some additional disinfection in a pipeline where it can be distributed to uses such as irrigation. That can be golf courses, apartment complexes, city parks, other parks, as well as processed water for industry. There's a lot of industry in Corpus Christi. That's an opportunity, as well as cooling water for industry and otherwise. Now, when we're talking about potable reuse, that comes in two primary forms. So we give labels to things. That can be indirect potable reuse and direct potable reuse. When we're talking about indirect potable reuse, that's utilizing an environmental buffer. So after the wastewater treatment plant, we're taking that relatively clean effluent water that's typically discharged to a river or to the bay and treating it through several other additional advanced water purification processes. So that's the AWPF, Advanced Water Purification Facility. And then that environmental buffer can be a reservoir, it can be surface water augmentation, it can be a river, it can be a constructed wetlands, but there's some sort of environmental buffer. It can be an aquifer even, in aquifer recharge or aquifer storage and recovery, ASR. Somewhere downstream or after some period of time, that water is then withdrawn again and goes through a water treatment plant. And so you might stop me right there and say, well, that happens all the time already in our rivers. We have discharges from upstream entities. We have downstream water treatment plants pulling that water out. And so we call that de facto IPR, de facto indirect potable reuse. Direct potable reuse is similar to IPR, but we take out that environmental buffer. And so we're going straight from that advanced water purification facility either into another water treatment plant where it's piped directly to that drinking water plant. So if you have an existing surface water plant like Owen Stevens, that would qualify as a direct potable reuse if we pipe straight to the raw water intake for that plant. Or in the case of what El Paso is doing, and I'll talk about, again, some of the projects happening in Texas, they're going direct to distribution. So they're taking right from the end of that advanced water purification facility and going into their drinking water distribution system with that water. Now, Corpus Christi operates a decentralized wastewater treatment system. You have 6 different plants spread throughout your system. So this presents both opportunities and challenges. In total, those 6 plants in aggregate produce about 25 million gallons per day of effluent. It fluctuates throughout the day, and it somewhat fluctuates a little bit seasonally. Mostly it fluctuates diurnally throughout the day. But altogether, it's 25 million gallons per day. Now reuse presents also a type of a drought-proof water supply, but with all of these supplies being decentralized, there can be a lot of cost in bringing those together. The opportunity it presents is doing a fit-for-purpose water reuse right there. Sometimes your best cost of water, your best value for the city of that next drop of water can be your local water, and reuse represents your most local water. It's right there already in the city. However, infrastructure costs can outweigh some of the benefits of certain IPR scenarios, indirect potable reuse. Because if we do have to pipe it really far, there's all those infrastructure costs, then it starts to, you weigh that against some of the other ones that you've seen today that have long, miles of pipe to get the water where you need it. This is just one example, a very, very rough example of how you might pipe water upstream of Owen Stevens and discharge it into the Nueces River so that you're then able to capture it at the intake for Owen Stevens. It's just an example. There's also an area that's been identified by Corpus Christi Water as favorable for aquifer storage and recovery. So this is also an indirect potable reuse option where we would purify the water to drinking standards and then put it back in the aquifer where it can be stored. It is resilient to evaporation, obviously, once it's in the aquifer. It's like a big storage tank, and then we're able to take it out at some time in the future when that water is needed. And so that area is around the airport and is something that would be evaluated as well as one of the options here. Okay, where has potable reuse been done in Texas? There's a growing number of potable reuse projects in the state of Texas. Unfortunately, the outline of the state is coming in kind of light here, but we've put some dots on the map. These are projects that are, some have already been commissioned and are operating, some are in development. I don't intend to go through every single one because of the time limitations, but I want to touch on a few of them. So I'll start with El Paso. El Paso has a very diversified water portfolio. They've been practicing indirect potable reuse through aquifer recharge at their Fred Hervey water reclamation plant since 1985. So through that project, they've recycled about 3 million gallons per day by recharging it back into the Hueco Bolson aquifer. And then more recently, beginning in 2011, they did a feasibility study of that direct-to-distribution DPR plant that I was referring to earlier. That'll represent about 10 million gallons per day and actually just broke ground on construction last week. I was involved in the conceptual design and pilot testing of that project back in 2015 and 2016. So they're really leading the way in terms of direct-to-distribution DPR in North America. Big Spring, Texas is the one DPR project in Texas that's still in operation right now. I mentioned El Paso is just broke ground. Big Spring has been in operation since 2013. And they recycle about 7 million gallons per day, and that entity is the Colorado River Municipal Water District. So they do the first type of DPR I mentioned, where it goes through advanced purification, and then it gets blended in with the other raw water for CRMWD at their plant in Big Spring, and so then all of that water that's blended together then passes through a conventional water treatment plant. So it's not direct to distribution, but it is piped directly to that conventional drinking water plant. Wichita Falls got their name on the map by being the first to do DPR in Texas back in 2011 at the beginning of the drought, and that was truly on an emergency basis. Not something TCEQ wants to ever have to do again, but they operated under an emergency permit for several years, DPR, and then once they were out of the drought and they were able to decommission the DPR project, they later came back in 2018 and did a permanent IPR facility utilizing Lake Arrowhead, and so they're doing surface water augmentation at Lake Arrowhead, and that facility is still operating in an IPR format. Currently, we're about to begin pilot testing of DPR in Liberty Hill, Texas, which will be initially a 4 MGD facility, expandable to 8 MGD. Their situation is really unique, and I'll have to talk about it another time because I just glanced at the clock, but I'd love to talk about that one sometime. Brownsville is looking at a feasibility study for IPR at their Robindale wastewater treatment plant, which will be about 14 MGD. So we've been working with staff on a scope of work to evaluate all the different alternatives that are out there for Corpus Christi. So it includes these scope items, project management throughout the project, coordination with TCEQ. As you can imagine, there's a lot of treatment that is involved when we're taking treated wastewater effluent and purifying it all the way to drinking water standards. There's a lot of coordination with TCEQ involved. And many of the ideas that we've already come up with the city, and I believe with some of y'all as well, that are ideas that we plan to evaluate, will take considerable amount of coordination with TCEQ to make sure that we're stepping through all the different things that they would want to see. We'll also do an evaluation of all of those reuse alternatives. The goal is that that's an exhaustive review of all the possibilities so that we can get the best possible value of water for the city of Corpus Christi. And it has to stack up not just only against the other reuse alternatives, but all of the other alternatives you're hearing today too. So as a consultant, we're not pushing one particular project. We're just here to say, hey, if you do reuse, this is what it's going to cost, and this is how you could do it. Once that alternatives evaluation, shortlists one or a couple options, we would then proceed with source water characterization, which is required by TCEQ. So that's a 12-month process of sampling, where we do sampling over that period to characterize the source water. In this case, the source water is not a river or a lake. It's treated effluent from the wastewater treatment plants. And then we submit that to TCEQ along with a pilot study protocol, and then we would go into pilot testing of the treatment system to treat that effluent. Okay. Thank you.
Great, thank you. Our next presentation is on Mary Rhodes improvements.
Good afternoon, Nick Winkleman, Director of Water Systems. Mary Rhodes Pipeline, as most of you know, it consists of a 101-mile pipeline from Lake Texana to the Owen Stevens Water Treatment Plant. Mary Rhodes Phase 2 was completed in 2016. That consists of a 42-mile pipeline from the lower Colorado to LNRA through Mary Rhodes 1 to the Owen Stevens Water Treatment Plant. Our water sources for both Mary Rhodes Phase 1 and Phase 2 consist of Lake Texana and the Colorado River. And a quick side note, we've been talking about total dissolved solids. The average between both sources is about 300 to 400 total dissolved solids. We have a contractual amount of water that we purchase from LNRA, and then we also have our water rights on the Colorado River. The LNRA contract also includes what we call 2 interruptible waters that can be made available by the LNRA. The Mary Rhodes Pipeline was designed with multiple pumping schedules. We are currently pumping at Schedule 3, which is approximately 55 million gallons a day. As you'll see, our plans are to go to Schedule 4, which will be approximately 75 million gallons a day. Completed in last year was our condition assessment for the Mary Rhodes Pipeline. This condition assessment was critical to the way we operate the Mary Rhodes Pipeline today. And I do want to mention that on Tuesday night, the team won an award for this condition assessment project, won the National Assessment Management Project of the Year. We were up against a project in Detroit and one in Florida. That was given at the Underground Infrastructure Conference in Houston. The team for that project consisted of CCW, and we're very proud of our folks who take care of the MRP every single day. Consisted of HDR, our consultant, the executive management team here at the city, and council for approving that assessment project. That assessment showed us that the MRP is performing satisfactorily. Past failures typically associated with access points, air relief valves, other joints within the pipeline. We also identified some erosion areas and some varying soil corrosivity areas that need to be mitigated through cathodic protection. The pump station upgrades, which were planned, must continue, and we made some modifications to that. The assessment also showed that we do have some obstructions and some pressure exceedances in the pipe. However, we cannot address those at this time because we cannot take the MRP offline. Since we ended up, as a result of this study, we initiated Schedule 3 operations on June 24th, and since then, we have brought an additional 2.6 billion gallons of water to the city. So our program goal is to operate at Schedule 4 in a reliable manner. This project consists of 3 phases: AEP upgrades, the Mary Rhodes and System Improvement Project, and the installation of combination air vacuum valves along the pipeline. The AEP upgrades are completed. That included additional transformers
and some other electrical equipment at both the Bloomington and Woodsboro pump stations. System improvement project is meant to upgrade both pump stations. We have VFD upgrades, pump upgrades, and as well as HVAC upgrades and valving and other improvements. The air vacuum valve installation, we identified 7 places that required air vacuum valves. This is a mitigation measure as we move to pump the pipeline at a higher capacity. What we see on the right is an active installation. It's what we call a hot tap on the Mary Rhodes pipeline. In summary, the AEP upgrades are complete. The air vacuum valve installation is expected to be completed on March 13th. And the pump station improvement project is in process, but the upgrades needed for Schedule 4 will be complete and ready. We're expected to go to Schedule 4 operations March 24th this month.
Okay, thank you. We're going to go into the short-term emergency water supply projects. We have 2, back to 5 minutes. Next presentation is on water wells along the Nueces River. Yeah.
I'll wait for the presentation to come up. Okay, the Nueces River Groundwater Well Program. First, I want to give you a little bit of history. Wells were utilized by the city in the 1950s to pump into the Nueces River to supplement flow. As we all know, that flow goes to the Nueces River intake station, which then pumps water to the Owen Stevens water treatment plant. This approach was last used in the 80s and 90s, where the program was revitalized and utilized again. So what we've done here is we took a playbook from the past and utilized it. Our goal is to provide a supplemental water supply into the Nueces River, potentially up to 15 MGD. First, we began investigation into the existing wells. 9 wells have been investigated. As you can see from the pictures, they were left in varying types of condition. In some cases, access was extremely difficult to get into. Pumping equipment was absolutely in poor condition. And we found a number of we haven't found a viable well yet. All the wells have been deemed to be unviable and not suitable for use. Our new wells, we've identified 7 new well sites along County Road 73. Those well sites are on existing city property. They're also in Nueces County. All of this is meant to move quickly and as fast as possible to get water into the river and head to the our pumping station along the Nueces River. As mentioned earlier, Weisinger Incorporated is our contractor, and they're finishing well number 1 right now. We plan to be test pumping by the end of next week. CCW crews will install the discharge lines to the river, and CCW crews and CC gas crews will be installing natural gas lines to each of the well sites. We plan to utilize natural gas generators to operate the wells. Sorry for the size on this map, but you can see that just the amount of the new well locations and the existing well locations that we've been working on over the last month. The new well construction, it's important to note the well will be cased and cemented first to a depth of 465 feet. That's 20-inch casing. The residential wells in that area are typically 150, 160, 180 feet deep. So we will completely case off those upper formations so there's no interference with the local wells. There will be a 26 underring borehole, and we'll install 14-inch production screen and casing. Again, we're set to begin test pumping on well number 1 next week. The drilling rig will be moving to well number 2. We'll have a better idea on productivity and quality at the end of next week. We have been working with TCEQ on our bed and banks permit, and they've been very receptive to our efforts. A couple other things to note.
Steve Young was also mentioned earlier, and I don't have his autograph either. But he's our hydrogeologist. He's working with us on this project. And these wells will target the lower Chico Formation and the upper Goliad Sands Formation, which is part of the Evangeline. So these wells will also target the Evangeline Formation. An important note about this program, the wells are on city-owned property. We're designing it in a manner so that this program will not die. Even after the western reservoirs recover, we will maintain these wells and keep the program up so that we can use it in times of future drought. Thank you.
Thank you, Nick. And our last presentation is on CC Polymers.
Good afternoon. Let's see, do we have the presentation? There we go. Okay, so again, Stacy Barnett, Ruben Munoz from CDM Smith. We've been working with the city on a conceptual study for Corpus Christi Polymer. And the goal of that conceptual study was to really look at the current plant and its current status, the desal plant, looking at the alternatives for how it could provide water to Corpus Christi Water, and then looking at drafting a term sheet, working with the city and Corpus Christi Polymer. So the first thing is the desalination plant that's already on site. It's a 9.4 MGD plant. It started construction back in 2016, so it's been around for about 9 years, but it's never been put into use. The treatment plant itself is about 95% complete. And in order to make it complete, totally complete, as far as startup and commissioning, finish the plant, startup and commissioning would be approximately 9 to 12 months from when it would have a contract with the city. So several alternatives were evaluated that included what I would call potable and non-potable type of options. The alternative that has risen to the top is displayed here. And what I'm showing first is on the top left side of that, you can see the CC Polymer plant. From the plant, you would take a 24-inch pipe to the east side, and you would connect into a new pump station on the top. And then you would, there's already a 24-inch, well, currently it's potable pipe that's being constructed underneath the ship channel. And then when you get to the south side there, you could have a new 16-inch pipe that would go either way to the east or west there. That could either, depending, it would either could serve industry at that point, or it could be utilized to go into the potable system. And the reason why I say that is because if we're looking at what is the fastest alternative, it is to, the water would be treated with one-pass RO, so that would not be considered potable at that point. It would be a non-potable system. It would be raw water. We would consider it raw water as a part of the Corpus Christi water system. The current 24-inch pipe that's already being constructed is important because it's already in process. That was already being done to essentially loop the system, and that will be done by this summer. So what we would be doing is taking advantage of the fact that that pipeline's already going to be in place and tying in to that from the Corpus Christi Polymer site and then distributing the water. So what would that look like? One, this plant, like I said, it's 9.4 MGD. It can be expanded in the future. It can go up greatly in size. The plastics plant would actually is expected to begin or expected to be in service within the next 3 years. So what we're looking at initially is a 3-year contract for the city, and with the potential to go longer term where it could go up to an additional 10 years. If it did get past 3 years where the plastics plant would need to utilize some of the water, then they would have to expand the plant. So there would be water available both for their purposes and also for the city at the same time. If it was only a 3-year short-term contract, then the city would be able to use the entire 9.4 for most of that time. So the fast solution would be utilizing the 9.4 MGD is essentially a raw water source with the one-pass reverse osmosis treatment, and it would be putting it into the system to serve likely industry on the other side of the ship channel. That would help because then that's 9.4 MGD that the industries do not need to use from O.N. Stevens. And then the longer-term solution, if you want to utilize this as a potable system, you could add treatment to make it potable, and it could serve others besides industry. But that would be the fastest. So the offset is the advantage there, because within 9 to 12 months, you'd be able to offset 9.4 MGD of use from O.N. Stevens to utilize for industry in that local area. That's all I have. Thank you.
Great, thank you. Okay, so now we will go to questions from our council, and we will start with Councilman Roy.
So my question is probably, Drew, I think you can probably answer most of them. And thank everyone for their presentation. So when I look at where we're at in terms of we've increased the Mary Rhodes pipeline by, what, 12.5 MGD so far?
Correct.
Okay, and we have the potential for about another 20. Let's just say that we'll yield about 30 MGD in that phase 4, correct?
So we're about 20 MGD in addition, so we're pumping about 55 million gallons today. So 75 is the target for Schedule 4.
But that'll give us an additional 30 since you turned on the
correct,
and you enhanced the Mary Rhodes pipeline, right?
Yes.
So 30 MGD is essentially kind of the same size of what we're looking at in the Inner Harbor. So with this solution, shortly here in March, we'll be at 30 MGD, right?
Correct.
And now we have these, we're drilling, and if I understand it, each drill site yields, is it 1.5?
We're thinking it's between 1 and 1.5 million gallons a day.
So I'm pretty accurate at that, and we think we've got 7 at the end of the day that will be viable. So let me just do the math quick. Maybe that's like 10 MGD?
10, sounds good.
So we had 30, we're going to have 30 in March with the phase 4. We got another 10 tapping into the Evangeline, right?
Right.
And so now we're at 40 MGD.
Right.
Okay? And on top of that, we're sitting here with CC Polymers, which we're saying in 12 months, we could have 9.4. I'm going to round up to 10, right? So somebody do the math, because I just...
50?
That gives us 50, right?
Right.
50 MGD. All right, okay. What overall, and so I guess what I'm looking at, has anybody looked at in terms of what our demand is right now? What is our demand and where we're at in terms of our drought? And looking at what we've just done here on things that we know that we have the ability to control and that may be successful. I say that, hopefully. I say CC Polymers because it just seems pretty simple thing. They already have a permit, right? They just got to turn it on. It takes them 12 months to be able to turn it on. These are short-term solutions that we could actually implement and put into place, right?
Right.
Then we have the Inner Harbor, which is another 30.
Right.
So what I would like to see is, in terms of looking at what our demand is, where we're at as far as the drought goes, what we know in terms of, so overall, that's 110 MGD, right?
Right.
And what effect that's going to have in terms of our water availability and looking at our drought overall. Does that make sense?
Yes.
Because I think that's important, and I think that at the end of the day that people want to understand that, because sometimes, everybody has a different level in terms of what we think is our panic mode. Where are we at? And so you've made some great improvements. I will tell you this, just to share this information, there was a group of us that recently visited, as you know, Kiewit in Kansas, and having the ability to, and I guess I can explain it the best way, is saddle up the water from the intake and look at the route and look at the process and look at how it goes through the system, how many MGD it takes. I think it's 84 in the beginning of intake, and as it goes through, and then at the end, we're going to get, and they said somewhere between 33 and 36 MGD. And just looking at the entire process, what they're doing as far as taking care of and being stewards of the environment and making sure that all of those things and the quality in terms of what's done through the output. And I really feel, I mean, we have committed ourselves, I believe, to the Inner Harbor. And so that's another project that we're midstream on. I mean, we're well into that project. And with that, I'll stop. But you know what I need.
Right.
Thank you.
Yes. I was just going to say, I think really the point that I think is important to note is that seawater desal, the groundwater wells, those are drought-proof water supplies. And so every one of those supplies that we can add on, we're building resiliency in the system. So, yeah.
Thank you, Drew. Councilwoman Campos.
Thank you, Mayor. And thank you all to the presenters. I know that seems like we've done this, so many times, but again, it comes up with the same questions. For me, it's still Inner Harbor, and the negative, I guess, not negative, but I guess opposition to this site. And the most opposition that I have been hearing is the environmental costs that it would affect. And I don't see that in your presentation. I mean, if it is, I mean, I think I've been asking for that for a while, about the far-field modeling and so forth. And even to this day, this is, this is probably, I guess, the closest or the one that we really have focused on. And for me, and I think for most of the public, it's the worst one. It's like the costliest, the worst for the environment. So the timeline, I'm just grateful that we have all other alternative, options. But really, the La Quinta, again, same thing, environmental. I really am asking about, I guess, the same thing is, and that's what I would like to see for every project is I would like to see like a matrix on the environmental costs, the timeline, which some projects do have them, the permits, which some do, how many gallons it will produce, and some of these do. And of course, at the end, it's always about the financial cost. So for me, I would like to see all these questions answered on the Inner Harbor, the La Quinta, and on the water reuse. I think most of these CC Polymers, on the permits for CC Polymers, are we still waiting on permits? Is that it? Are we?
No, we're not, Councilwoman.
We're
they
done
have all
with the
their
permits.
permits.
Okay,
Yep.
just making sure. Okay, and as far as the environmental, do we have impact on the environmental from CC Polymers? What would happen if, for instance, there were to be damage to our water? What would be the responsibility of CC Polymers, or would that fall back on us, on the city of Corpus Christi?
So CC Polymers has a permit.
Yeah, no, but I was asking about the environmental.
Well, I mean,
if there was to be an impact, a mishap to which we've been, according to some of our scientists, it's not the best place to have a desalination plant. So who would have the cost? Who would be to blame?
So well, CC Polymers would ultimately be responsible, but at the end of the day, there's a permit. If we can't meet the permit, the TCQ has the authority to shut down that facility if you can't meet the environmental requirements.
But we have, seen other disasters through our, our time where things do happen even when you have all the permits. So again, I'm just wanting to make sure that if we were to go with the CC Polymers, I just want to know who would be responsible if there would be something happen to our bay and that it would damage our marine life. So it would be back on CC Polymers. Okay, I guess that's it. Thank you.
Thank you, Councilwoman. Councilwoman Paxson.
I think we have 5 minutes.
Yes.
So I'll try to go kind of quick. My first questions are regarding the Inner Harbor project. We had the 1 page of information, and I couldn't help but feel kind of like this is an item that we have pretty consistently poured most of our efforts into. So I would have liked to see an actual itemization of those things you kind of rapidly went over as our next steps, because I feel like, rather than focusing strictly on historicals and big picture timelines, what I'm really interested in seeing the details on what is the reality of our next few steps on that. And I know you mentioned, there's a permit coming up next week, those things like that, and it's not in the presentation. So if I were to need to go pull that up again, or the public or anyone, it's not in there. So those are the steps that I'd like some clarification on. The next question was regarding the effluent water. We have here in front of us an option for a more long-term solution, and I like that direction because it certainly seems at face value to present an option that capitalizes on the most reclaiming potential. But what part of the study, if any, have we discussed a more short-term, a more quick turnaround for repurposing some of that?
Yeah, these are not really quick projects. They tend to be long lead projects because of all the testing and sampling that has to be done and all the regulatory side of it. However, I think the lowest hanging fruit for a short-term solution is the non-potable reuse options. So one of the things that we would consider in that evaluation of reuse alternatives tasks is, are there industries that can take non-potable reuse now, basically a quality of water that these treatment plants are already producing, and can we pipe it to them? If they're using the city's potable system, that offsets potable demands, and so that would have a benefit of freeing up potable demand. So those would be your lowest hanging fruit in terms of a short-term response.
Okay, and then I assume that there's a pretty clear path to trying to get that included in this project to look at something we can offset a little quicker.
Yes, Councilwoman, there is. Next week, we'll show council we already have a part of the reuse in the works with our OSO wastewater treatment plant. We're offering free to landscaping entities, anybody that wants it, type 1 water. So there's a distribution system. There's a route of how they come in to get the water. We just completed it about a week ago or so.
Right, so type 1 wastewater reuse is available to the public at no cost. And we were in Austin, and actually the executive director, Noelle George, who runs the Texas Water Reuse Program, was telling us that we are the first city in Texas that makes available type 1 water at a fill station like we have. So that's a great resource for the community to be able to take advantage of.
I do applaud and commend those efforts. I know that as recently as about a week ago, you and I have conversed over, helping some of the community access that, and I do appreciate that. In addition to those efforts, looking at something that's a little more tangible than just, having it on the table as an offering, is actually being able to convert and calculate how many gallons are we able to put back into the system. That's kind of more my path on that. But thank you for that answer. It sounds like we'll go back on that. On the Mary Rhodes pipeline, if our capacity, according to this presentation, is around about 75 to 79 million gallons a day, that's max. What's realistic? Like, what are we anticipating to actually be harvesting from that?
So the pumping max, the pumping is set for 72 to 79. Typically, I'm estimating 75, 76.
Okay, and the capacity on that pipeline is what the 79 is?
That's the pumping capacity. So when the pipeline was originally designed, the pumps were designed to pump those different schedules. Right?
My thought process is going, if we were to add other sources into that stream, such as we talked about Evangeline, something like that, what are we realistically harvesting? What's our maximum potential? Where's the difference there?
Yeah, that's a great question, and it's a lot to discuss. It has a lot to do with the different pumping stations along the pipeline. So we have a pumping station at Lake Texana. There's one at Bloomington and one at Woodsboro. And we have to look at the injection points and then look at the pressures on that line. What we found out from our condition assessment, we have obstructions in the pipeline. There's certain areas right now, when we operate at Schedule 2B, they exceed the pressure rating of the pipe. At Schedule 3, we're okay. At Schedule 4, we're okay. The introduction of any water into the pipeline has to be looked at, so we just match those pressure ratings.
Thank you very much.
Yeah.
Thank you, Councilwoman. Next, we'll have Councilman Gil Hernandez.
Okay, first of all, I'll say I'm a little disappointed that we didn't have more pricing of what the cost is for any of this in any of your presentations. I think that was a miss. The only one that I did see pricing on, and he never got to it, was from Garver, cost of around $185 million for the, but what volume was that for?
Actually, I'm not sure where that came from. I didn't intend to present any pricing, but it really depends on what alternatives come out of that evaluation. It can range. It really depends on the amount of treatment that's required. We're not going to know that until we go through the source water characterization and work with TCEQ on how much treatment is required. So between the infrastructure costs and the treatment costs, it can vary significantly.
So does 185 million sound correct?
I would say it depends on the option, but that's probably low for the amount of flow that I think the city is looking for. It depends on the size of the facility as well.
Okay.
You didn't present any figures, Dan, right? You did not present any figures.
No.
Right.
I don't think there were any numbers in the presentation itself.
I'm sorry, it's in the presentation here where it says $5 million for water smart recycling desalination, $800,000 for piloting, and $180 million for large-scale water recycling.
So those are three different funding programs offered by the U.S. Bureau of Reclamation.
Okay, so you're talking about funding that's available for these kind of projects.
Exactly.
So but you don't have an idea of what it would cost for.
That would be some portion of the project. That would be some portion of the project that could be covered by grants from the Bureau of Reclamation.
Okay, so that you didn't get to that portion of it, so I'm assuming that there's wastewater reuse is highly valued in terms of for the federal government grants, right?
There's a lot of federal funding actually out there for these types of projects in the western U.S.
We need some estimate as to what that would cost on a per 1,000 gallon basis to see if that's a viable solution. Going on to the next question. Thank you very much.
Okay.
The cost for the improvements to the Mary Rhodes pipeline. In the capital improvement plan, it has about $30 million. Is that still accurate?
Yeah, so the cost for the Mary Rhodes, we have a CIP project, which was about $13 million. And then there's
two Mary Rhodes. Phase one, one is for prior years for 13.9 and then 13 for this year.
Correct. So part of that 13 for this year, Councilman, we're using for the ARV upgrades, which is, I think it's about $1.5 million, right? And then we have some costs for AEP as well.
Okay, so can you tell us what the additional volume of water that we got on a per 1,000 gallon basis is going to cost us?
So the other thing I want to bring up, just to be complete on the cost picture for those improvements, so there is a change order of approximately $1.8 million that will come to council in March as well. Those for our additional electrical upgrades
on the 2 pump stations.
Okay, so when you
Right.
bring that to us, you need to give us what the additional water that we were able to capture from Schedule 2 to Schedule 4 and what that additional cost is on a per 1,000-gallon basis. I think it's pretty reasonable, honestly.
It is very reasonable. One thing to note is some of the upgrades are HVAC, so those
It's
pump
fine.
stations are
It's fine.
25
All
years
factor it in.
old. You know,
We
it's
all factor it in. Also, on a cost per 1,000 gallons on the pump state, on the wells, what that cost is.
Yeah, so the wells is a very good news story. So we received we received emergency authorization on January 27th. That was for $10 million. We had another project for 1.5 to investigate the existing wells, and we're not going to use all of that.
Okay, so like I said, we want apples to apples here on what cost these water sources are costing us. Because we kind of know where some others, and I don't have a lot of time here, so I want to ask one last question here. CC Polymers, what's the cost per 1,000 gallons? And is it raw water? Is it treated water? What water is it?
So right now, we are working on finalizing a term sheet, so it's not completely negotiated. We should be coming back to council in the next 2 weeks.
Ballpark it for me.
7 to 750 a thousand.
Okay, so is that going to be industrial water or is that going to be potable water?
That would be the industrial.
Okay, so and if our
Which would be
do we have a price model for industrial water? Like on a schedule? So what would we sell that for?
Well, we haven't gotten that far, Councilman. We don't have that yet. We're working through those numbers.
Okay, so that needs to be very specific.
Thank you. Thank you, Councilman. Next, we will have Councilwoman Vaughn.
Mr. Molly, I'm going to focus on what ifs,
Okay?
okay? Once the desal plan goes online, what happens if it starts to rain, if we're so blessed we get some rain? Can you slow or stop the water production down so we can save money?
Well, there's some flexibility that is built into this new plan. I will say infrastructure likes to run at its design criteria, and it's designed to be 33 to 36 million gallons a day. We're still kind of working that through, but ultimately there's different trains that you run these facilities. So you could potentially drop down an order of basically like a 10 million gallon a day threshold. So you could reduce the flow through that plant. Obviously, we all know that this facility will be more expensive water than some of the other facilities. So we think that, to your point, I think I get your question, which is, can we use this plant only to the degree that we need to save costs for a ratepayer? And I think the short answer to the question is yes.
Okay, I'll give you another one. What would happen if we had 100-year rain? It happens, we haven't had it, but it happens. And the refineries could not keep up with their stormwater, or all the oily sewer and their wastewater treatment plants stopped working. All of that would go into the ship channel. What then? Will it be safe to continue to operate the plant?
One of the things that I think is really important, and I appreciate that question, is we have an obligation to ensure that we protect public health. So if there was ever an incident such that you described where we could not meet the requirements, we would derate the facility, meaning we would lower the flow, all the way to the extent if we couldn't treat any of that water, we would have to shut the plant down. Now that's no different than what could happen, for example, at Owen Stevens. We could have a spill on Lake Corpus Christi. We could have somebody dump something into the river, and that could potentially cripple our ability to treat that water at Owen Stevens, which would be very similar to the incident that you just described. And I've seen this happen. I've actually, not here, but I've experienced this, where large amounts of rainfall contribute to lots of sediment, and a water treatment plant like Owen Stevens just cannot treat the water. We can't meet the turbidity requirements, and we end up having to shut the facility down, or big parts of it. So I would say that the example you just described is something that could happen at the Inner Harbor. It could also happen at Owen Stevens as well.
Okay, well, it's important to look ahead and be prepared for an emergency like that. So I'm just asking, what would happen if a refinery had an oil leak and all that stuff went into the ship channel, or two barges collided and they oil? What would happen? Would the plant shut down then, or it would be the same scenario?
Well, I'll tell you, couple things really important is having real-time water quality sensors, and we need more of them. We have them for Owen Stevens. We will have them in the ship channel so that if we detect anything that is not meeting certain thresholds, that would be an alert system for us where we would either be on the radio having somebody go out and take a look, or if it was really bad, we would just shut the facility down just to minimize any issues with the plant. Because I think we heard somebody say earlier that membranes, the high-pressure RO membranes, are very expensive, and it's all about making sure that you protect those membranes. So if you were to not shut the facility down in a timely fashion, you could really have a problem with infrastructure damage from those membranes.
Okay, so there's things in process for
Yes.
that. Okay, let me go back to something y'all said a while ago. You said, I want to understand it. Today, we're pumping 55 out of Mary Rhodes. In a month or so or sooner, 20. That's 75. Where did the 30 come from? I'm trying to figure out what Everett was talking about, Councilman Roy.
He had three sources, Councilwoman, the Mary Rhodes, the wells at 10 million, and then the CC Polymers at 10 million.
Oh, so he was
Yes.
counting. Well, that's 20, not 30.
But no, 10 from the Mary, 20, let's see, 20 from the Mary Rhodes and 10 from the wells. I guess it was just those two.
But we already had
Evangeline.
10.
Okay.
We already had 10 that we pulled, or 12.5.
Right.
From the Mary Rhodes already.
Okay.
Yeah.
I'm
It
just trying
was
to
a-
clarify.
Yeah,
Okay, it's not something we have, it's something we're hoping we're going to get.
that's the answer.
And the last quick question is for the Mary Rhodes pipeline. You said there was obstruction in the pipeline, right?
Yes. Well, when we did our condition assessment, one of the things that we did was we put a number of analyzers along the pipeline corridor, and we saw, and this isn't unusual, but there were some locations where there was exceedances of the pressure rating of the pipe. And so that's always a little bit of a concern. You don't want to exceed the pipeline pressure capacity rating. But it also tends to, those locations where those exceedances were in locations where there were drops in the pipe to cross rivers. And so the only way to really address that is you would have to shut the line down and likely put somebody in it or a pig or some sort of cleaning mechanism, because probably what's happened is there's been sediment that's built up. And when that sediment builds up in those locations, it does cause pressure exceedances.
And we will have to fix it eventually.
Absolutely.
Your time's up, ma'am.
I know it is. Mr. Sinoni, I know you're going to take note of this. I'm sorry. But we're going to have to, because we went so long without repairs and maintenance on that line. So down the road, we know we have to do that. It wasn't under you, but it's before you got here.
Yeah.
But just a note.
Right, yeah, we need to, so the condition assessment we did finally gave us this data, and now we have to wait to when can we take it offline, but that's part of the plan. Nick, you can see the quality of the presentations and the assessment that these new leaders are doing in our CCW, and so maintenance is a big part of it. Not only the Mary Rhodes pipeline, but our own Stevens treatment plant, our lines that are in our neighborhoods. So, yeah.
So in the example that you gave, when we get all that rain, when it happens, it's going to happen. Immediately, what we're going to do is we need to get into that pipeline, the Mary Rhodes, we need to take it down, and we need to go in and do those condition assessments when we don't need it, because we have plenty of water from the other sources on Choke Canyon and Lake Corpus Christi.
Thank you, Drew. It's okay, it's Drew's fault.
Oh, sorry.
Keep talking. The clock already went off, the alarm clock. Councilman Scott.
Well, first of all, Drew, I heard you talking about putting a pig in the pipeline. I think that's cruel, and I don't support it. I want to be very clear about that.
I heard pig also.
Yeah, I've been, my wife's worried about me because I spend more time with the water guys than I do at home. So I love you guys. But let me tell you something. I am really, really frustrated with our lack of having an adequately presentable model to tell us what happens if we add this water supply and if we add that water supply. I mean, the question is, how do we get the desal? And let's assume it's May or July of 28. If we add 10 from the river, is that good enough? If we add 10 over here, and I'm really frustrated. The one we have with Corolla is half done, and then it got out in the media, and it looks like we're going to run out of water, next May or something. So I really want that model, Peter. It's fascinating to me that we're having these conversations without a model that provide data. Now I'm going to run real fast because I got. So I want that model. And I think Everett was right there. He goes, he's asking the same questions, but if we get that model.
Ran out of time.
I know. I got you, man. That was for you. Can I have some minutes back? No. Isn't the pipelines designed for 100? It was built for 108 MGD, but the pump's really going to get us to 79.
Correct.
MGD.
Yes.
If we run the pumps at 79 MGD, can we add another 10 MGD somewhere in that system? Because it's 1 million gallons a day, but we only have, 70,000 acre feet. And my question is, and in fact, answer it later. So if we use all that, and I think we should have a conversation with Formosa. They took that water from us, 10 years ago. They're not using the water. Now, I'm sure we're going to have to pay them what we made them pay us, but there's 10,000 acre feet that went to Formosa that they clawed away from us because they had a project in Lake Jackson. There's 10,000 acre feet they're actually not using. They just took ownership of it because they could. So my question is, can we get that in the system? We operate 78, 80 for 365 days a year, and can we do that, right? So I'm running out of time. So that's the question.
Yeah, the answer is yes, and we'll be back at council with that in about 2 weeks.
If it works, I want all the credit. If it doesn't, I never brought it up. Is there anything else? Okay, so couple of questions. Tell me later. I don't even know where the location is for La Quinta. I just never paid attention. So can somebody just send me a map or call me later and say where it's at? And I'm curious which one was the intake and the discharge. They look different colors. You can tell me that later.
Send it to the whole council, for that matter.
Okay. Yep. Okay. I'm so excited to get all wrapped up here. The pipeline, see, that was the question that you were trying to ask, was how much is in the pipeline and how much more can we put in? But I will tell you, if you get the Formosa water, there may not be any more room down the way for our friends up in Evangeline. That might impact their ability to, or our ability to buy water south of them. But you can ask. You'll answer me that later. I was going to ask you water quality. Let me just close with this. I want to suggest that if we guys send you all out in any additional water supply conversations, we ought to fund it. The conversations I get into is, Mark, don't do anything else. Don't have staff do anything else except that which is before us today, all these short-term water supplies, and tomorrow, which is desalination. We have got to get to whatever it is, May of 2028. That doesn't mean these other projects aren't important, and I believe they're incredibly important. But all I ever hear is, don't run out, show me, prove to me, which the modeling might, that we're not going to run out of water between now and desal, and that we're really going to do desal because that gets us out of this pickle. Right. So my plea to you all is if we have conversations with you about a couple of these other projects, then get permission to go hire somebody to do the work, because we really want you guys focused on the projects in front of you today and tomorrow. And with that, I get 48 seconds back, Mayor.
There you go. Thank you for donating those.
Can I get them?
No. Okay, Councilman Barrera.
Okay, real quick, La Quinta, timeline and cost, real quick.
2030.
2030, cost?
Costs around 1.1 billion.
1.1 billion, thank you.
Timeline is what, 2030?
2030, so cost per thousand?
Around $10 and, where did I write it? $10.62.
Okay, and then we'll find out what a blended rate will be. We'll figure out a blended rate later on. Okay, so, and then I'm going to try and get you as much time. So here, I'm speaking the same thing. So 75 MRP, 10 CC polymers, 15 from the wells, that's 100. And then my perspective is that Evangeline, if that were 6 months and we get that 12 MGD, that puts us already up at 112. So I think if we ask for the same thing and saying that this is our timeline, 6 months, 12 months, where does that put us? Because I can tell you that right now in Austin, everybody's hair is on fire because the majority of the economy comes from oil and gas. And, the entire world is looking at us. So having that out and making sure that we understand and the public understands, because $12 water runs people off. It really does. They say, we're going to go to Oklahoma and Louisiana, and I know some people would rather have that, but I, for one, am not one of them. So the other thing is now, Drew, that you've seen all these. You know, I remember when we put together this stakeholder group 10 years ago, and because that's the same thing. You have the 9 laymen up here, of which I would say that everybody's smarter than me. The guy that comes a very close second is a soda fountain salesman. I won't say which one that is, you know, but the thing, but anyway, I guess he figured out which one it was. But anyway, the point is that, you know, we're talking about TDS, we're talking about, you know, salinity levels, we're talking about wastewater reuse. And I would say, I know I'm definitely not qualified to be able to make those decisions. So there has to be, just like we did back then, an RFI to put together what's the cost associated with it. Because what's happening is that we're taking up all your time and saying, hey, this guy just called me. He's got a great project. This person just called me. He's got a great project. You know, somebody contacted me on Friday and says, hey, you guys need to consider this. And you guys, the staff are the experts, you know. I mean, they're the experts. And the thing is that somehow has to be vetted, just like we did before with an RFI. So, because right now, I think if you put these short-term items and the NRA, I mean, you're looking at 400 MGD. And we just said in July, we only need 120. So why would we engage in a project that cost us, and not picking on them, but $12 water? That's how we came up with the Inner Harbor. The Inner Harbor was, you know, it's close to the demand center. What is it? It's close to the demand center. That's going to reduce the cost. What is it? This is what we need. 30 MGD will get us to step 1 and keep us comfortable. I mean, that was vetted over the course of 5 years, Jason? 10? So that was vetted over that. Then we said the next step would be La Quinta, which is if we needed the demand, it's right by San Patricio. So that's already been vetted. And so now because we have such a sense of urgency now, what is it? All of a sudden now every project is important. Everybody's got an idea, and it's creating a ton of confusion. So homework number 1 is put that amount that we've been asking, hey, where are we going to be once we have this 10 MGD in? Where are we going to be once we add this other 15 MGD? Where are we going to be? That way we give confidence to the consumer and then confidence to industry so they have certainty, you know, a predictable regulatory environment. I wanted to give you an opportunity to say something. So that's what I say. Number 2 is, once again, perhaps, and it's not for me to decide, it's the entire body to decide, that we put together some kind of stakeholder group to put an RFI, so that way we can vet a lot of this, and then that gets presented to the council and not us, because I know I'm not an expert. Now, I've got 6 years of listening, but I'm not an engineer. And I was never a naval officer. So that's why I say just a little bit smarter than me. So anyway, but so comments about how this could move forward, and it could be either Peter or Drew. You got 8 seconds.
Go ahead.
I love this.
Drew?
Yeah, Councilman, as I said to KIII, much of this, many of these projects are in the works already, but we don't have a quick answer for you today. But what we need to do is digest what we heard today, come back with the council with a recommendation, and see if council wants to proceed in that way. But on this list of these projects, several are being discussed. Just yesterday, we just discussed 2 actually, and Dr. Mintz was here. This Friday, the port will consider funding for that project. So many of these are in the works. We'll present that recap to council. And the goal is, as I've seen it, is we want to see what is the next 1, 2, or 3 in that order, so that we're doing just what you said we won't do, which is be scatterbrained and working all over the place. And every time a new idea comes up, we drop everything and now take on that. So we need clarity from the body, the governing body, of what do we want to pursue next, then after that, and then after that, or 1 or 2 simultaneously. We know the Inner Harbor water treatment plant is well underway. It's under design right now, but what's the next source? Right. And where do we focus our most precious resource, which is our time, right? So we can't do all of these. with the staff we have today or the resources we have today. So I think this is a good beginning, but we have to come back to this body to say, what do you want us to focus on so we can use our time and resources to meet that, rather than being non-focused and then just being all over the place and coming up with nothing.
And Peter, I might add to and support the comments just made, you know, to the points made, we're not water experts. We're not engineers. We cannot pretend to know what the feasibility, viability is, sustainability is of Barney Davis or, you know, Evangeline or anything else for that matter. So to me, you know, you all have, and I know you're not saying this, but this is a huge, I don't even know how Drew is standing right now between testifying in Austin and being pulled in a million places, and I spend much time with them. I'm not asking a question. I have a recommendation because I know where we are, and I think some great questions were asked today. But I think, as mentioned, I believe that, yes, we have to bring this in, but we need your help. Anyone, I don't care who thinks they know more, they do not. And it is your job, it is all of our staff's job, it is all of these people who are here, paid by the city in some way, to advise this council. And that's where we have to be strong. If people want to run off and, you know, explore the world, by all means. But this council has to come in and say, what have we invested in? What do we know about the project? We cannot just do things right and left and forward and backward. Y'all can't do it. And today, I think, was a big step forward. I'm not saying this exercise wasn't advantageous to the public and the council, but moving forward, I can tell you, we are moving forward in a direction. The train is moving. It has been moving for 10 years. In terms of our project, we're almost there. We've got, a week, right? Next Thursday.
Yeah, next Thursday.
We're almost there. That's great. But now we have phase 2. This was a perfect entrance to what are we going to look at or what direction are we going to go in phase 2? But we need you all. We need you all to say, you know, based on what you know, what you do every single day, here's our recommendation, right? And then we work cohesively to move in that direction and be efficient. So that said, here's my recommendation today. Don't have questions. We've answered them a million times over. We need an accurate reflection of our water supply calculation. Because today we are basing everything, stage 4, upcoming, on 2 western reservoirs. They have nothing to do with an extra 20 MGD, right, being added. Another 10 MGD or 9.4 being added. Another, what's the other one? 7, let's just go with 7 to 10 MGD being added when those things happen. So the first one we already know is March 24th. So Peter, if we took 20 MGD and converted into, what is it? Yield, firm yield, right?
Firm yield, yeah.
Right. I mean, this needs to happen because we're not inclusive of the diversity that we are creating right now. And that has everything to do with the DCP. And that's coming next week. And I recognize you can amend that anytime. But my request to you is to go figure out, and again, I don't know how complicated that is, and I know TCEQ, it has to be involved in that, but it's the perfect timing because this is coming next week. So if we can change those trigger points based on, I don't know, maybe that's only based on what is about to happen, you know, March 24th, or maybe we have to wait until that actually happens. Again, I don't know the rules and regs of any of this, but we need to change that now because if we can prevent stage 4 justifiably, we're going to pour, again, I don't know how, the drilling, I don't know how long that's going to take, but nonetheless, 20 MGD is going to make 18%.
Right. Yeah, the
Go up to something else. So I think this is the time though now, Peter, because this is coming next week.
That's what we have in there. So the stage 4 would be based on all water sources, not just the western reservoirs. It'd be all sources, including any new one that comes on.
Right, but
Yeah.
well, we'll talk offline because
Okay.
I think we're missing. I don't know. Again, we have to talk in detail, and I won't take this time to do it, but I think that's critically important.
Yeah.
Is there anything else you want to add?
No, that's it. Just that we do have this information and we're hearing it loud and clear. So we'll show it next week as part of the DCP. That being, where does our demand exceed our supply?
Right.
The forecast for that and layering in when the wells come on, when the more water through the MRP, when CC Polymers comes on. So yeah, we'll show that to council next week.
So I think, thank you. We are actually on track. So it's 2:00. So we're going to wrap up this workshop. Thank you very much. Thank you all for being here. Drew, your team, everyone who's here. Thank you. Jason, everyone. We appreciate it. Thank you.